is okay, so I hope I'm clearly audible. Everyone, give me a quick response. I'm really sorry for the delay. There was a lag from my end. So I hope I'm clearly visible and audible, everyone. No voice. I hope I'm clearly audible now. Everybody, give me a quick response. Great, 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 great. Sincerest apologies for that no voice. I hope now I'm clearly audible. Everyone, give me a quick response. So we are getting started again. I am telling you that for class 12 students, those who are preparing for JEE, this is the series which we have started. So anyone and everyone who's preparing for IDJ can watch it. And in English, we are catering you all. In between, we were engaged with some students who were class 11 students who have created some initial chapters of the Arjuna batch as backlog. So that backlog we were covering previously, but now we are back with your series, Methods of Differentiation. So I hope you all can hear me, you all can see me. Thank you so much for showering so much love, appreciation. Thank you so much. Shall we get started, everyone? I hope you all can hear me and see me, everyone. Great, great, great. So if it is running smoothly, let's get started. Methods of differentiation. So basic differentiation will be starting with, of course, some previous year's questions as well. So standard decent concepts one after another and the various methods to differentiate will be discussing. Sir, is this one shot sufficient for IITJ preparation? I mean, if I just watch this one shot, will I become eligible for, solving JEE Mains or advanced level questions? Of course not. Then sir, why should I watch it? You should watch it if you want to understand it theoretically and conceptually. And of course, up to an extent, we'll be doing a practice, a decent amount of practice. But of course, to attain that comprehensive, thorough understanding, you need that step-by-step guidance. You need that lecture-by-lecture guidance on this chapter, which you may not be able to get through a single one shot. So of course, if you're covering it as a backlog, of course, you're treating it this one shot as a revision session, you can. But otherwise, yes, you should understand this chapter as a complete series or a sequence of chapter, one video after another video. Please understand right now it is not that late where you'll start watching one shots. But yes, if you want a revision, a quick revision of this chapter, yes, you should not miss it, everybody. So what are we doing here? We are discussing methods of differentiation. So we are done with functions. A lot of chapters already we have done, but in this series of calculus, when we started with functions, we have moved towards limits, continuity and differentiability. And then now we are discussing methods of differentiation. In this chapter, we'll learn different ways to differentiate, different methods to differentiate. But here, after MOD, we call it in short MOD, methods of differentiation, we'll do AOD, applications of derivatives. And that chapter is more crucial and more important. But sir, if that chapter is more crucial and more important, why are we not studying that chapter directly? Because to learn AOD, you need MOD, application of derivatives. So you apply differentiation directly. You see the real world applications of it. But to do that differentiation, you should know how to differentiate. And that method of differentiation we'll discuss here. So different ways to differentiate we'll be discussing in this chapter. I hope I have clarified my agenda. You are clear with what are we going to do today. I hope there is no confusion regarding that part. So previously, if I could simply tell you what all we have covered. So we have covered a lot of things technically speaking. We have covered basics of maths. We have covered matrices. We have covered determinants in this one short series. We have, of course, covered inverse trigonometric functions. Then we have covered functions as well. Then we have moved towards limits, continuity and differentiability. And after covering all of this today, we are moving towards MOD. After MOD, we'll cover AOD, then of course, indefinite integration, definite integration, area under the curve, and a lot more will happen. Differential equations will come, and that's how we'll cover your whole syllabus through these one shots. Today, if I could simply tell you what I'll be doing, we'll be first of all understanding the meaning of differentiation. That what is the meaning of differentiation or derivative. There, I'll tell you the geometrical meaning and of course the algebraic meaning. Both meanings I'll tell you of differentiation. Then there are multiple methods like differentiation through logarithm, differentiation through, differentiation of implicit functions, differentiation of explicit functions, parametric differentiation, differentiation of a function with respect to another function. All these different methods will be discussing. Inverse functions, derivative, composite functions come into picture, chain rule come into picture, quotient rule, product rule, and everything will cover here. That any sort of problem if you ever encounter on differentiation, you would be able to do with these methods which we'll be discussing. So anybody who wishes to revise all those different techniques, approaches to learn various approaches to figure out a derivative of any expression or function, here is a lecture for you. Did you all get this? So shall we get started? Before we get started, I simply want to tell you the basic meaning of derivative. What is that? Let's say there is a curve. Of course, you'll have a y-axis and you'll have an x-axis, right? So if you have y-axis and x-axis, what you do here is, let's say this is the curve where it goes like this, right? Now, please pay attention, everyone. On this curve, let's say there is a point. Let's say there is a point x. Let's say this is a point x is equal to a, right? This is a point x is equals to a. And just a little further distance away from this point, there is one more point, which is x plus del x. I repeat, let's say this point on the x-axis is a or x, whatever you wish to call it. Let's call it x. And this point, del x distance away from it, on the rightward side of the x-axis, let's say for a while, there is one more point, which is of course del x distance on the rightward side. So it will be x plus del x, where this is a curve y is equal to fx. So the x coordinate of this point is x. So the y coordinate here will be fx. So here, this point's x and y coordinate will be x comma f of x. Everybody agrees with me on this? Similarly, when you talk about this point's coordinates will be given by x plus del x. The x coordinate and y coordinate will be f of x plus del x. Correct me if I'm wrong. Everybody comfortably processing it. Now, Newton and Leibniz came up with this conclusion that when you talk about the curve, geometrical meaning technically I'm speaking. So when you join these two dots, these two dots are you noticing and seeing? So of course, it looks like a secant to this curve. It indeed looks like a secant to this curve. And coordinate geometry's intelligence, if I apply, what I'll say here is that, sir, if you want to figure out the slope of this secant, let's say this is a secant AB, the points are A and B. So slope of this secant AB, so I hope coordinate geometry has told you or taught you y2 minus y1 upon x2 minus x1. So y2 minus y1 upon x2 minus x1 will be what? This is y2, which is f of x plus del x minus y1, which is f of x, divided by x2 minus x1. What is x2? X plus del x minus x1. What is x1? That is x. So this is how you define the slope of this secant. Okay, but the story doesn't end here. What they did was, they said, what if we use the concept of limit over here? So what does it say? They said that here, if this del x is not as huge as this del x starts reducing. Sir, what will happen in that case? So, sir, if I want this del x to be as small as possible, as less as possible, that I can achieve with the help of limits. In limits, continuity and differentiability, we have learnt it that with the limits, we can attain it. Remember that, everyone? So, if I introduce the concept of limits, where I say limit del x approaches 0 on this slope of AB, I can call it slope of the line AB, of the secant AB. So if del x is approaching 0 on this secant AB, now pay attention, everyone. When del x is approaching 0 on this secant AB, what are we going to attain now? Pay attention, everyone. Pay a lot of attention, everyone. Pay a lot of attention. If this del x is approaching 0, don't you think gradually you will start having this del x reducing? Let's say del x reduces to this, so B point will come here. So this secant will look like this. Let's say del x reduces to this, so the B point will come here. So the secant will look like this. If del x reduces more, so this point B comes here. So that secant will look like this. The more close you become towards x, the more del x this reduces to. Don't you think you will be very close to A? And when you are very close to A, don't you think that this secant will actually become a tangent? Yes, Akhilesh, I think we have done it already. If you visit the channel only, PWJ English, we have done it. Definitely, my friend Pankaj Garg. We have created a lot of videos on that. Strategy videos, if you watch on the videos section, you will watch it and you'll get it. So I repeat, my point is pretty simple. Del x if you start reducing, as small as you make it, you will see it will come very close to A. You will see it will come very close to A somewhere here. And in that case, when you draw the secant, it won't be a secant anymore. It will start behaving as a tangent. Are you getting my point, everyone? Or shall I repeat it? What did I just say? I said that if del x approaches 0, the B point comes very close to A. And in that case, this does not behave as a secant, but rather as a tangent. And if it becomes a tangent, what is my point? What is my point? My point is pretty simple here, students, that here in that case, there is a point on this curve x comma f of x. And on that point, if you are drawing a tangent to this curve, so I think I am able to find the slope of that tangent. I am able to find the slope of that tangent. So I repeat, when I say limit del x approaches 0 on f of x plus del x minus f of x divided by, it was x plus del x minus x, so x and x are cancelled, so it is del x. So this thing here is nothing but what? Of course, in a simpler sense, we call it a right-hand derivative and left-hand derivative. In this sense, it is right-hand derivative. And if the differentiability is there, we have discussed it in LCD already. So this is called the derivative of this curve. This is called the derivative of this curve. As per the first principle, the ab initio method, the basic principle of differentiation which you use, all the formulae which we are going to discuss, like derivative of e to the power x, derivative of x to the power n, derivative of sine x, all those formulae are derived from this basic formula only. But my point here is pretty simple, that here, if you are finding the differentiation, then we have finally cracked a formula where I'll be saying that geometrical meaning of derivatives is what? Geometrical meaning of derivatives is slope of the tangent to that curve at that point. Which means here, if I do this f of x plus del x minus f of x by del x, when del x is approaching 0, we call it geometrically we call it the slope of the tangent to the curve at x comma y, or you can call it x comma fx. Are you understanding my language? And Newton-Leibniz called it ddx or dy by dx. So they called it d dx of fx. Fx is y, so we may call it y. Or this whole thing is called as d dx of f of x. At what point? At the point x comma f of x. Everybody understood it. Everybody realized the geometrical meaning. Similarly, one thing also we noticed that here only, when we observe this, that sir, when slight change, when very small change in x happens, then y is also changing. So I'm going to explain the algebraic meaning now. I am saying that algebraically, don't you think that differentiation dy by dx or ddx of f of x would mean change in y with respect to change in x. So rate of change of y with respect to x is called dy by dx. I repeat, let's say here this x got changed. This x was something here and it got changed to this. So when a very small change happens in x, then there is a small change in y, because originally y was here, then y became this. So if previously y was this, now y became this, so there was a change in y. Are you noticing this? So if x changes a little, y also changes. So if I wish to observe or notice rate of change of y with respect to change in x, with respect to x, then it is called dy by dx. That's the algebraic meaning. Let me know. I have explained you two things, the algebraic meaning of ddx and the geometrical meaning of ddx. Did you all get both? Did you all understand both? Or shall I re-explain this? All the participants, did you all get this? Shall I move ahead from here? If you all got this, if you all have understood it, if there is any confusion, do let me know. I'll re-explain. Everybody. For example, let's say we have this, a function y is equals to x to the power n, right? And I want to find out that what will be the change in y with respect to x. So what I'll use is differentiation ddx. So although we know the formula, but what if I ask you that you can find it through ab initio method? What is ab initio method? Ab initio method means the standard basic principle. So what is that? There I'll say that here if I want to find f dash x, what am I asking you is ddx of f of x, which we call dy by dx, which we also call as f dash x. So they all mean the same thing. Differentiation of f of x with respect to x, differentiation of y with respect to x, which with the help of Newton-Leibniz coefficients we write as ddx of y or ddx of f of x. dy by dx also we call it. But here, what is the major concern here is that you should understand that ab initio method, the basic principle, what does it say? So that you can understand where did we or how did we get all of these formulae, where you say derivative of sin x is cos x, derivative of tan x is sec square x, derivative of x to the power nx is nx to the power n minus 1. So how are you getting all of these formulae? That's exactly what we are discussing here. Everybody, please pay attention. So basic principle of differentiation, if I use, what we know is that this ddx or f dash x, whatever you wish to call it, will be given by limit del x approaching 0. For a while, can I say del x as h? Can I treat del x as h? I hope it's fine. So this will be f of x plus h minus f of x divided by x plus h minus x, which is h. Everybody comfortably getting it? But sir, how is your f of x defined? Sir, f of x is defined as x to the power n. So if f of x is defined as x to the power n, what I'll be doing here is limit h approaches 0, f of x plus h. So f of x plus h will be x plus h raised to the power n minus f of x, which is x to the power n, divided by h. Everybody comfortably getting it? Any confusions if you have, please ask. All the participants, do let me know. Now please pay attention everyone. If I take x to the power n common from here, if I take x to the power n common from here, so this is limit h approaches 0, x to the power n I have taken common from here, so it becomes 1 plus h by x to the power n minus x to the power n whole gets divided by h. Are you processing this? Any confusion so far? What did I do? I took x to the power n and x to the power n common, and this whole can be taken common outside, and there I say limit h approaches 0. X to the power n, when you take, what you are left with is 1 plus h by x whole raised to the power n minus 1. Comfortably got this everyone? And this thing gets divided by h. Any confusions? Now what if I ask you to do one thing? Sir, what thing? Here, tell me if h is a very small value. In a binomial theorem and even in limits also, we have learnt this expansion that if 1 plus x to the power n you do, and if x is a very small number, then we can write it as 1 plus nx. I repeat it. What I'm saying is if 1 plus x to the power n you do, and x is a very small number, then this can be written as 1 plus nx. Remember that. This you study in binomial theorem, and this you study in limits as well. Same idea if I extend here. I hope you do accept that here this is x to the power n. So limit h approaches 0, x to the power n outside, and here you have 1 plus n h by x. Yes or no? So 1 plus n h by x minus 1, correct me if I'm wrong, whole gets divided by h. Yes or no, everybody? Now what you clearly see is that, sir, this one and this one are cancelled. So this is x to the power n times n h whole divided by x times h, where h is approaching 0. This h and this h are cancelled. So finally, what I get is x to the power n by x times n. So this will be n. X to the power n by x is x to the power n minus 1. There is no h, so limit also gets vanished. What is this? This is f dash x. What is this? What is this, students? What is this? I hope you do realize that this is nothing but what? This is your ddx. ddx of what? ddx of x to the power n, which we received as nx to the power n minus 1. How many of you were aware of this ab initio method? This basic principle of differentiation, the first principle of differentiation, that actually Newton and Leibniz have found all those derivatives, like for sin x, cos x, tan x, sec x, cot x, all those functions were actually differentiated with this standard method. So this is that standard rule, and I hope it makes complete sense. Did you all get this? Did you all understand this? All the participants, do give me a thumbs up if you all have understood it. Shall I move ahead from here? Shall we go further from here, everyone? If everybody is comfortable. Now, this ab initio method, if I use, we can work out a lot of formulae for differentiation. For example, wherever and whenever we are differentiating a constant function. So constant function means what? It is purely constant. I mean, it is not changing. So if it is not changing, change in y with respect to x will be nothing, because y is a constant function. So in that case, there is no change. So dx of a constant will be 0. I hope it is self-explanatory. Similarly, by using that ab initio method, or the first principle of differentiation, if I work out all of these formulae, I hope I need not tell you this formula, that sin x when differentiated with respect to x is cos x. Similarly, cos x when differentiated with respect to x, it is minus sin x. Similarly, tan x when differentiated with respect to x, it is sec square x. Cot x when differentiated with respect to x, it is minus cos x square x. And sec x when differentiated with respect to x is sec x tan x. Now here only, in this chapter only, I am telling you the reverse formula as well. Integration is the opposite process of differentiation, which means if the derivative of c leads you towards 0, so integration of anything 0, or I mean any constant, will be x. What did I just say? I'll explain it with the formula. But right now, I am saying that if differentiation of sin x is cos x, then do remember that integration, sine of differentiation is ddx, sine of integration is this. Integration of cos x with respect to x will be none other than sin x. Of course, constant of integration also we put. What is the reason behind this c? I'll tell you later some other day when I teach you indefinite integration, but I hope you will remember this formula as well. ddx of cos x is minus sin x, so you will remember, I hope now, that integration of sin x will be minus cos x. Of course, plus c will be there, which we'll understand our study later. Similarly, when you integrate sec square x, so its integration you will receive as tan x, and plus c will of course be there. Along with this, when you integrate cos x square x, so you will find its integration to be minus cot x. Its integration will be minus cot x. Similarly, when you integrate sec x tan x, and there you will see its integration to be sec x. So are you understanding these reverse formulae? The story doesn't end here, it actually begins, or it actually starts. Derivative of cosec x is minus cosec x cot x. Remember, for sec it was sec x tan x, but for cosec x it will be minus cosec x cot x. So their integration of cosec x times cot x with respect to x will be minus cosec x. Plus c will always be there. Even if I forget, you should understand it. Similarly, this is a formula which we have just derived. Pay attention, everyone. n should be a rational number here. It should not be an irrational number here. The power, the index we are talking about. So x to the power n, when differentiated with respect to x, gives you nx to the power n minus 1. So in that sense only, I hope you do realize what is happening over here is that x to the power n, when integrated, n gets multiplied and the power get reduced by 1. So when you integrate x to the power n, what should happen is, sir, n should divide it, but it's not actually n. The power is getting increased by 1 because opposite you should do. So it was n originally. I hope you're getting it. So what you should do here is x to the power, to make it to the original power will get increased by 1 and this will be divided by n. So that is the integration of x to the power n. Are you understanding it? Everybody processed this. Any confusion if you have, please ask. Similarly, when you talk about ddx of ln of x, the natural base e. So there, ddx when you do, what it gives you is, pay attention everyone, 1 by x, where you should remember this, that whatever argument you are passing to ln, it should always be positive, yes or no? So there, opposite is also true, which means inverse. If you ever integrate 1 by x, then never follow this approach that here integration if you do of x to the power minus 1, you start applying this formula x to the power minus 1 plus 1 upon minus 1. No, that you don't follow. Here n is clearly not minus 1. I hope you do get this. You do understand this. N is clearly not minus 1. If n is minus 1, in that case you apply this formula that when x to the power minus 1, that is 1 by x is integrated with respect to x, it is ln of x. It is ln of x. Of course, plus c you append here. Are you processing this, everybody? Now, similarly, few more very interesting formulae get generated. Derivative of a to the power x is a to the power x ln of a. Similarly, if you ever integrate a to the power x, if you ever integrate a to the power x, so what you'll get is a to the power x divided by ln of a. So it will be a to the power x divided by ln of a. I hope you got it, plus constant of integration. I hope the most beautiful thing in mathematics you all must have learned is this, a to the power x. So we should be like v to the, did I make any mistake? Oh yes, I'm really sorry. I am really sorry. Thank you so much for highlighting it. Vijay, thank you so much. Thank you so much. I don't know. I made a mistake. Thank you so much for correcting it. Coming back to this discussion, e to the power x. So you should be like e to the power x in life. What is e to the power x, students? E to the power x is a function which never changes, So after differentiation and integration, it remains same. So even if you integrate e to the power x with respect to x, it will be e to the power x. Plus you'll definitely append, which is not a matter of concern. Here, these are some more important, more crucial formulae which you never forget, which you should never forget. What are those? Let's have a discussion on them one by one. Sine inverse x. First of all, of course, we know that, sir, here x should lie between minus 1 and 1, closed interval, yes or no? So if I ever ask you this integration, integration of 1 upon under root over 1 minus x square. So remember this now, that here also x should stay between minus 1 and 1. And this time it should be open, because if it becomes minus 1 or 1, it will not be defined. So in that case, its integration will be sine inverse x plus c. Will you all remember that? I hope there is no confusion. Similarly, for cos inverse x, the differentiation is minus 1 upon under root 1 minus x square. So there what I'll say is that if you ever see same expression but with a negative sign, let's say this minus 1 upon under root over 1 minus x square dx. So sir, in that case, here you can write it as either cos inverse x plus c. But sir, what if I put this minus sign outside? You can. So if you put this minus sign outside, it will become minus of integration of 1 upon under root over 1 minus x square. So in that case, this integration will be negative of sine inverse x, because this is sine inverse x. Are you processing this? Are you getting this, everybody? Do let me know if there is any confusion. So what did I just say? That cos inverse x when differentiated is minus 1 upon under root 1 minus x square. Similarly, memorize it, by heart it, because this is what you'll use a lot and very often, especially in differential equations. So tan inverse x when you integrate, gives you 1 upon 1 plus x square. Of course, here x can be any real number. So here also x can be any real number. So what I'll say here is that integration of 1 upon 1 plus x square with respect to x, you should not hesitate in writing as tan inverse x. Are you processing all what is being said? Any confusions in this slide on these formulae? Everybody comfortably got them? Few more there are. For example, here, whenever you wish to differentiate cot inverse x, it is same as tan inverse x, but with a minus sign. So you'll get minus 1 upon 1 plus x square. What does it mean, sir? It means that if you ever see minus 1 upon 1 plus x square needs to be integrated, then you can clearly say it as cot inverse x. But sir, what if I put this minus sign outside? Definitely you can. In that case, it will be minus of 1 upon 1 plus x square. And for this, we know the integration is tan inverse x plus c. I hope there is no confusion regarding this. Everybody getting it comfortably. But there are two more. Right now, there are two more. What are those? First of all is sec inverse x, and second is cosec inverse x. And mind you, students, for sec it is positive, for cosec inverse it is negative, which means here, if you are differentiating sec inverse x, it is 1 upon mod x times under root over x square minus 1. So when this is integrated, which is 1 upon mod of x times whole square root of x square minus 1 with respect to x, you should not hesitate in writing that it will be sec inverse x. And of course, without any discussion, I'll say that if minus of 1 upon mod of x times under root over whole of x square minus 1 needs to be integrated, it will give me minus I have used here. So it will give me cosec inverse x. Sir, what if I take this minus sign outside? You can. In that case, it will be minus sec inverse x. Everybody got this. Everybody understood it. Any confusions if you have, please ask. Shall I move ahead? Shall I move ahead? Whatever we did you all get this? A very simple, a very silly example if I wish to take. I can explain it with very silly, very direct example. I hope you process it. Let's say if I ask you x to the power 10, the derivative. So you know the formula. Don't you know this? Sir, x to the power 10 when differentiated gives you what? 10 x to the power 9. I think you all are currently studying 12th. Know these basics. Hello everyone. I hope you're getting it. Yes or no? So with this, shall we do a good question here? Shall we try a good question, a brilliant one? Now, let's try this question. Of course, you can also solve along with me, and the moment you solve it, you're supposed to write your answer in the comments. Shall we, everyone, give it a try? So this question here says that y is defined as root over 1 minus cos 2x upon 1 plus cos 2x, where x is given as either 0 to pi by 2 or pi by 2 to pi. And then they are asking you the value of dy by dx. Anybody, even if you are in 11th, we would appreciate you should, because differentiation you will keep using in your entire 11th standard in physics. So there you'll need it a lot and you will be able to understand it up to a good or a large extent. I'm sure of this. Coming back to this. So what am I saying here is, pay attention everyone. Do you remember that identity from your 11th standard days? In Trigo you study cos 2x has majorly two versions. It has actually 4 versions, but majorly these 2 versions we very often use. 1 minus 2 sine square x and 2 cos square x minus 1. So if I push this one here, one identity more gets created, which is 1 plus cos 2x, which is 2 cos square x. And if I rearrange this from here, I get 1 minus cos 2x as 2 sine square x. So these two, I would humbly request everyone to memorize. Sir, why? Because IIT JEE is madly in love with these two identities. They will keep using them almost everywhere. So how do we solve this? Pay attention everyone. We say that 1 minus cos 2x is clearly 2 sine square x. We say 1 plus cos 2x is 2 cos square x. So let's substitute it. So when I substitute it, y gets what? Under root over 1 minus cos 2x, 2 sine square x. 1 plus cos 2x, that is 2 cos square x, and this is inside an under root. Mind you students, of course, what we see is 2 and 2 are cancelled. So what I get is under root over sine upon cos is 10. So it will be 10x whole square. But one more thing you all must have studied is that, sir, x square inside an under root is not x, it is technically mod x. So this mistake Some of you have committed again. Some of you have committed again. Thank you so much, my friend. But here, pay attention, everyone. You're making a small mistake, a very small mistake. That is mod x square, sorry, x squares inside an under root is not x, it is mod x. So Vijay, Piyush, everyone, those who have gotten it, correct it. And that's where they have given you a part where you should be more careful. So there I'll say y will not be 10x, it will be modulus of 10x. So far everyone with me? So far everyone with me? But story doesn't end here. Actually, you know that 10x graph if you notice, or even the quadrant theory if you notice. So 0, pi by 2 and pi. So in the first quadrant we know all are positive, so 10 is also positive. Yes or no? But in the second quadrant sine and cosec are positive, so 10 is clearly negative. What I'm saying is in the first quadrant, tan theta or 10x is positive. In the second quadrant from pi by 2 to pi, we know 10x is negative. Remember that discussion, everyone? So why are you saying this, sir? I am saying this because if I want to resolve it, I'll say mod of 10x will be plus 10x in the first quadrant. So as long as x is from 0 to pi by 2, it will stay like that. Thank you so much, my friend Shashank. Thank you so much. Now let's study. Thank you so much. But here I know that from pi by 2 to pi, 10x is clearly negative. So if 10x is clearly negative, when mod gets removed, to keep it positive, I'll put a negative sign. So it will become minus 10x. Are you all getting it? So in that case, x went from pi by 2 to pi, which means when 10x is in the second quadrant. When 10x is in the second quadrant, it has to be clearly this. Everybody with me so far? Any confusions if you have, please ask all the participants. Do let me know if there is any query or concern. Then sir, what? Now differentiate. This is your actual f of x or y. So those who thought that 10x is the final x or y, there they made a mistake. Vijay and I think Piyush, did you all realize it, everybody? So there if I differentiate it now, I'll get the complete or the right or the full answer. Shall I, everyone? So if I continue further, what I get is, first of all, f dash x or ddx or dy by dx I am trying to find. So that will be given by, pay attention everyone, mod of 10x, which is 10x or minus 10x. So derivative of 10x is what? Sec square x. Derivative of 10x is sec square x with a minus sign. So it will be minus sec square x. Of course, here, whenever x is in the first quadrant, 0 to pi by 2. And here, whenever x is in the second quadrant, pi by 2 to pi. So that's your full, complete and final answer. So everybody realized that you should be very careful with all those steps you perform. It's not sec square x. The correct answer will be sec square x or minus sec square x, depending on which quadrant you are in. And that's exactly why they have given you these two quadrants. Any confusions? Did you all understand this question along with its solution, or are you having still any confusions? Shall we quickly discuss some rules, some basic rules? I hope you know that if I'm adding two functions, if I'm simply adding two functions, let's say one function is f of x, other function is g of x, and I want to differentiate them. So over addition or subtraction, I am saying over addition and subtraction, very soon, Shashank, my friend, very soon will bring JEE Advanced problems as well. But let us get done with all the basics, all the concepts, all those one-shots, and then we'll bring practice-oriented sessions as well, dedicated for JEE Mains and Advanced. Right? Now, coming back to this, but here if you want to get conceptually strong with all the theory and formula and learnings, here these are the one-shots for you. Coming back to this, I am saying that over addition or subtraction, ddx, that is differentiation, is distributable, which means I can write it as ddx of f of x plus minus ddx of g of x. Whatever I'm saying, kindly listen to that only. Don't listen to what I'm not saying. People often listen to what I don't say. I said that differentiation ddx as an operator can be distributed over addition or subtraction. I did not say that it can be distributed over product or division. So I hope you did not listen to that. I did not say that, right? So if I could apply this property on some of the questions, let's give this question a try and let's try this. Some of you may think, sir, how are we going to do it? Some of you may think, sir, how are we going to do it? Definitely, Vishal, I will. partial differentiation I'll do when I'm going to talk about implicit functions. So their differentiation we'll be discussing. I'll be sharing a short trick with you regarding the derivative of implicit functions using partial differentiation as well. So two methods I'll tell you there. So there I'll be explaining it. Don't worry, Vishal. Coming back to this, I hope some of you may have noticed that, sir, in this question, instead of straight away differentiating it, it's better that you multiply this and this. So I hope you remember the basic identity which you all must have studied is a plus b times a minus b is clearly a square minus b square. So if I use this factor and this factor, it is a plus b and a minus b. So y is going to be what? A square minus b square. So x to the power 1 by 4 whole raised to the power 2. So it will be x to the power 1 by 2. And this is 1 plus x to the power 1 by 2. Everybody got this? Yes or no? That's good, Vijay. Brilliant. Now with this, we again apply the same identity, a plus b times a minus b. What is that? Again, a square minus b square. So it will become y is equals to 1 into 1, 1 minus this square. So x to the power 1 by 2 whole square is x. So first of all, this is the y. Great. Now, if this is the y, can you not differentiate it? So that's the easiest question from today's discussion. Now, we have just discussed that over addition or subtraction, ddx can be distributed. So what I'll do is ddx of 1 minus ddx of x, yes or no? And we have just learned that for any constant, Shashank, let's focus. For any constant, the derivative will be 0. And for x to the power 1, derivative will be 1 into x to the power 1 minus 1, which is 0. So 1 into x to the power 0 is 1. So 1 into 1 is 1. So for x, remember the derivative is always going to be 1. For constant, derivative is always going to be 0. So it will be 0 minus 1. So again, Vijay, it's minus 1, right? So the ddx of y here will be minus 1. Everybody understood it. I hope this was easy, understandable and doable. And I'm sure most of you must have cracked it. Everybody, yes or no? Yes or no? Do let me know if there's any confusion. Now, shall I explain chain rule to you? Shall we discuss the chain rule? What actually is chain rule? Let's have a discussion on that. Let's say I'm given a function inside a function. So f of g of x I'm given, and I want to find its derivative with respect to x. I want to find its derivative with respect to x. I repeat, derivative in the world of mathematics can be given by dash sign as well. So I want to find ddx of f of gx, which I can write as dash of f of g of x, which means derivative of f of g of x. Yes or no, all the participants? Now, chain rule here says that if you use composition of functions, which means a function has a function, another function as its input. So chain rule says use outside-in approach. What is outside-in approach? Outside-in approach means that treat g of x as x. If you for a while imagine that there is no g of x, it's simply x, so it is f of x. And then write derivative of f of x. So derivative of f of x is f dash x, but x is not x, it is gx. Getting it, everyone? Thank you so much, my friend Sachin. But now, this gx, which you have assumed as x, should be differentiated as per chain rule. So chain rule says now differentiate gx. So gx when differentiated with respect to x will give you g dash x. Let me just take a very simple, very silly and straightforward example so that you can get it. The chain rule I'm technically talking about. Let's say I want you to find out ddx of sine of e to the power x. Everybody getting it? So what does chain rule says here? See here, it says, that's good, Vijay, that's brilliant. Everybody keep it up, that's really nice. Imagine, of course, this is sine x composes, having a composition with e to the power x. So sine x has an input e to the power x. So in place of x, we have e to the power x as an input of sine. So it is a composition here. So what do we do, sir? In that case, we use outside-in approach. So outside-in approach means, first of all, I'll differentiate sine function. So derivative of sine is cos. Derivative of sine is cos. But sir, sine does not have an input x, it has an input e to the power x. So derivative will be cos e to the power x times this whole gets multiplied with the derivative of this inner function. So outside in. So inner layer when I reach, I need to now differentiate e to the power x. So e to the power x when differentiated gives you e to the power x. So this will be the chain rule. I am sure most of you must have cracked it by now. Yes or no? So if I could use that logic, can you help me in finding dy by dx here? I hope that's easy. You are now intelligent enough to directly write the answer. Sir, if you want us to find dy by dx here, we'll be saying outside in approach you should use. So it is a sine of something. So sine when differentiated gives you cos. So this should be cos of this. Yes or no? Sine of x is cos of x. But sir, it is not sine of x. It is sine of x square plus 1. So as per chain rule, x square plus 1 should also be differentiated. So derivative of x square plus 1 I'll do. Everybody getting it? Yes or no? Are you processing this chain rule? So with this, of course, derivative is cos of x square plus 1 whole gets multiplied by derivative of this, which is 2x plus 1. Did you all get this? That's beautiful. Good, Sachin. That's brilliant, Vijay. Any confusions if you have, please ask. Everybody got this? Oh, I'm really sorry. Why am I committing such silly mistakes? I am really, really sorry. There is no plus 1. I'm really sorry and humbly apologizing for this. It will be simply 2x. I'm really sorry for that. So I hope you got this. X square plus 1 when differentiated gives you 2x. Yes or no? All the participants. I hope that was easy and understandable. There are no confusions or queries. Let's apply it further on one more problem so that you understand chain rule in a more better manner. Yes, it is 2x. I don't know why am I committing such silly errors today, but anyways, anybody on any day can commit errors, but it's better that you don't commit it again. So here, this is a very good example to understand chain rule. How do we penetrate from outside to in? How do we do that? Let's talk about that. So here, first of all, let's rewrite this y. So this y is ln of sine of x cube by 3 minus 1, yes or no, whole raised to the power 1 by 2. Definitely, Shashank, for class 11th and 12th, both will do it a lot actually. Very soon. Very soon, these one-shots will be brought for class 11th as well, Shashank. We have planned it. So, here if I start discussing, imagine this whole expression is x. So, originally the outermost function is x to the power 1 by 2. Imagine the outermost function is x to the power 1 by 2. Imagine this. This whole thing is nothing but x. So, can you help me with the derivative of x to the power 1 by 2? Sir, x to the power n. What is x to the power n? Sir, x to the power n is n x to the power n minus 1. N x to the power n minus 1. What is n minus 1? N is 1 by 2 minus 1. So what is 1 by 2 minus 1? That is minus 1 by 2. Thank you, bye. What is 1 by 2 minus 1? Minus 1 by 2. But sir, originally x is not x. Originally x is this, which is ln of sine of x cube by 3 minus 1. And 1 by 2 minus 1 is minus 1 by 2. So this should be minus 1 by 2. So sir, are we done with this question? Beautiful, Krishna. That's excellent. 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 You can disturb me as long as you are having any doubts, my friend Shashank. We are here to address your concerns and queries only. So it's not called disturbing us. It's called getting your queries clarified. So whenever you are in a fix, having any problems or concerns, you should definitely, undoubtedly, unhesitatingly approach us. As teachers, it is our job to help you. But sir, are we done with this question? Absolutely not. I have simply differentiated the outermost function. So now I'll penetrate layer by layer, like onion you peel, the same manner. So the next layer will be, so outermost layer is sorted. Now we are dealing with ln of something. So imagine, how do we differentiate log x? Of course, this x should be positive. So if you have ln x, its derivative is 1 upon x. So ln x derivative will be 1 upon x. But what is x? Unfortunately, it's not just x. The argument here is this, which is sine of this cube by 3 minus 1. Okay, sir, one more layer we have penetrated. The outermost function was x to the power 1 by 2, like x to the power 1 by 2. Then other inner function was ln of x. But it is not simply x, it is sine of something. So now my next level will be the other inner layer, which is the derivative of sine function. And derivative of sine, you know, is cos x. So here it will get multiplied with cos x. But am I having cos x? No, sir. It is sine of x cube by 3 minus 1. So it will be cos of x cube by 3 minus 1. Yes or no? Yes or no? Yes or no? With this, sir, you should penetrate to one more layer, which is x cube by 3 minus 1. And that's the innermost layer, I think. You don't have to delve deeper. So there I'll say this final innermost curve function when differentiated x cube by 3. So we know when you wish to differentiate it, ddx can be distributed over addition or subtraction. So ddx of x cube by 3 minus ddx of 1, can you imagine it in your brain? So ddx of x cube by 3, I will be ruining this boy's face, the beautiful boy's beautiful face. So am I allowed to? I hope nobody will feel offended. We have students in our paid batches. They get offended when I ruin this person's face, this beautiful child's face. I hope no offense taken here. So now I'll be differentiating x cube by 3 minus 1. So x cube when differentiated is, can you imagine this in your brain? 3x square by 3. So this 3 and this 3 are cancelled. So it is x square. So this will be x square minus 1. When 1 is constant, which is differentiated, gives you 0. So you'll be left with x square. And I can write it with a simple ink only so that you don't feel confused. Everybody got this. How many of you genuinely got dy by dx as this? I'm sure you may not be able to write it in the comments. It's such a complicated expression, which Vijay, I think, Sachin, everybody has tried writing. Excellent, beautiful, that's really amazing. But I'm sure some of you may definitely have gotten this answer. Alpha Wolf is saying that, is it enough for JEE Advanced? I would say no, absolutely not, to be very honest and genuine. But it could be the starting, the stepping step for JEE Advanced. First of all, we are understanding the chapter here. Then we'll emphasize the practice. So the foundation level, if you want to develop on this chapter, this is for that. To be very genuine and honest, my friend Alpha. Absolutely, Sachin, it's a very beautiful answer with a very beautiful question. Have you all understood it? Any queries or any confusions if you have, please ask. I'll re-explain. Shall I proceed further from here, all the students? If you all have gotten it, yes or no? So when I move towards the next concept, it is called product rule. What does it say? Very beautiful, very simple, straightforward, direct rule it is. ddx of f of x into g of x. Now I told you that ddx is a distributable operator on addition or subtraction. But it is not distributable just like that over product or division of functions. Chain rule is a totally different phenomena which we have understood. But here, if I'm applying ddx on product of two functions, so what do we do here? We say, we read it like this. First function as it is, which is your first function, times ddx of second function plus second function as it is times derivative of first function. Did you all get this, or shall I repeat it, all the participants? Let me know if there is any question or query or concern. I repeat, with an example, I am saying, let's say if I wish to figure out ddx of ln of x times this ln of x whole times, let's say, sine of x. This is a function. So of course, it is a product of two functions where one is ln x, second is sine x. So sir, how do we differentiate it? How do we differentiate it? So you keep any function as first, any function as second. As far as it is product, it doesn't matter. So keep first function as it is. So ln x stays like that times derivative of sine x. What will be the derivative of sine x? Sir, we now know derivative of sine x is cos x plus second function as it is, which is sin x times derivative of first function. So ln x when differentiated gives you what? 1 by x. And that's your answer to this question. Of course, if you wish to simplify, you can write it as cos x times ln of x, yes or no, plus sin x by x. Everybody with me? Great, great, brilliant. That's good, Sachin. So if there are no confusions so far on whatever we have done, do you mind trying this question? And before you mind trying this question, I'd like to tell you one more method or one more approach. Let's say I'm given three functions. Let's say one function is f of x, one more function is g of x, one more function is h of x, and this needs to be differentiated. So then what do? Let's say there are 4, 5, 6, 7, 8 functions. Their product is done. How do we apply this product rule? That's what I'm trying to teach you. You just begin with any of the functions. Let's say I begin with the first function. So differentiate the first function, keep the other two intact. Plus differentiate the second function, keep the other two intact. Plus differentiate the third function, keep the other two intact. So are you developing the modus operandi, the standard operating procedure for 4, 5 or 6, 7 functions? Even if I give you a product of 7 functions, differentiate first, keep 6 same, plus differentiate second, keep other 6 same, plus differentiate third, keep the remaining ones same, and that's how you write this derivative of product of certain number of functions. Let me know in the comments, did you all get this? Did you all understand this when I'm explaining this trick you may call, but of course it's not a trick, it's simply an approach which we'll be using. If more than 2 functions are given, this is how we apply product rule on the product of functions when we need to differentiate. Everybody got this, yes or no? Please reply. I did not get any response yet. I'm still waiting, everyone. Nobody? Okay, no worries. So there, let us take a very quick example so that we can apply it here. So if I ask you ddx of y, so ddx of y, if I want to find, I'll say ddx of x, so derivative of x is 1 into other two as it is, which is sin x into log x, plus ddx of sin x, which is cos x, and keep other two as it is, which is x and log x, plus ddx of ln x, which is 1 by x, keep other two as it is, which is x and sin x. Are you comfortably getting it now? Great, 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 Samriddhi. Yes, Anubhav, thank you so much for asking this. But now we are here. Let's study properly. Everybody got this. I hope it's matter of simplification now. So ddx will be sin x ln x plus x cos x ln x, and it is simply x and x is getting cancelled, and it leaves you with sin x, and that's your final answer. Everybody, I think, was able to think like this or do like this. It was clearly not a very difficult or huge or lengthy question. Did you all get this, all the participants? Do let me know if there is any confusion. Now there comes one more, which is called quotient rule. This is somewhere students do feel confused. So listen to me very, very, very carefully now. Let's say I'm given 2 functions where their division is being done. So numerator is fx, denominator is gx. So fx upon gx needs to be differentiated. Absolutely, Vijay. Very good. Great, Sachin. So there it says denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator, whole gets divided by square of the denominator. What did I just say? I'll explain it with a very layman language if you could process it. I am saying, let's say I want to find ddx of numerator upon denominator, right? This derivative I want to find. So numerator upon denominator's derivative as per quotient rule is given by square of the denominator. It's not doctor, it's denominator. And then you keep denominator as it is and differentiate the numerator minus Keep numerator as it is and differentiate the denominator. Everybody got this, or are you still feeling confused? Quotient rule, are you able to process? Sir, we still are not able to get this. Can you explain it with an example? Of course, don't you worry about that. Let's say I'm given something as sin x upon x, and I want to find its derivative. How will you find it? First of all, just follow this process, that square the denominator in the denominator. So denominator is x, simply square it. Then what you do next is, then write numerator, derivative of numerator into denominator as it is. So denominator as it is means denominator is x. Derivative of numerator, so derivative of sin x is cos x minus. Now numerator as it is, which is sin x, into derivative of denominator, so derivative of x will be 1. I hope everybody understood it. Any query or confusion if you have, please ask. Do you have any doubts, concerns or queries? Everybody understood this, yes or no? All the participants. Everyone with me? That's great. So if you have gotten this, shall we try a good question here? A decent, simple and straightforward question. All the participants. Everybody give it a try. And before you try this question, shall I ask you one more different question? So what is that question? So before you try and answer this question, I want you to help me with a simplification of this, where I'll say that this is the expression, right? Cos x, cos 2x, cos 4x, cos 8x and cos 16x. This is an identity which we teach you in trigonometric functions and identities. So anybody from 11th standard, if attending this from Arjuna batch, you may be able to recall this, that this is something we have already studied, haven't we? That's great, Samriddhi and Sai Shravan. That's brilliant. So now, how do we solve this? Everybody, give it a try. So, the idea is really simple. The moment you see cos getting multiplied and the angles are in GP. If the angles are in GP with a common ratio 2, so there is a standard approach you follow, although there is a direct identity which you can apply, but even if you don't remember it, you can follow this approach. What is this approach? You are given cos x times. By the way, meanwhile, can somebody tell me what is the identity I'm talking about? In the comments, you let me know. I'll be really happy and glad. This will be cos 4x times cos 8x times cos 16x. Now this whole is getting divided. This whole is getting divided by what? By nothing. So just to do something really beautiful here, can I multiply it by 2 sin x? Sir, this is not your father's shop, so that you can do anything. If you are multiplying it by something, should you not divide it by something, so that the equation remains balanced, so that expression does not change, of course. So what I wanted to do here is, I wanted to multiply it by 2 sin x. I just thought of doing something. So to balance it out, what I did was I divided by 2 sin x. Absolutely, sir, we can do it. So when we do this, what we see or notice or observe here is something really beautiful. Can you let me know what is that beautiful thing? Can you let me know what is that beautiful thing? I hope some of you may have noticed 2 sin theta cos theta. Do you remember that? I hope this identity you all must have studied. 2 sin x cos x is clearly sin 2x. So that identity from Trigo, if I apply, this result is clearly sin 2x. Then you have cos 2x. Then you have cos 4x. Then you have cos 8x. Then you have cos 16x. And so on. That's it, I think. And then this result is getting divided by what? This result is getting divided by 2 sin x. Got this, everyone? Got this, everyone? And that's your y, by the way. Sir. Absolutely, Charang Golapudi. That's good. If I'm pronouncing your name correctly, that's good, Sachin. Aditya Mishra is saying, sir, my backlog in continuity. Should I start? Sorry for your time. You don't have to apologize, first of all, my friend Aditya. You have your backlog in limits, continuity, and differentiability. Before this one shot, we have released 2 one-shots. One is dedicated on limits. The second one was dedicated on continuity and differentiability. So in that depth or detail, we have covered it. So if you go and watch those also, it will be covered. You have my assurance. Coming back to this, now again, I have this genuine innate desire to multiply and divide it by 2. So are you all realizing or noticing something? I hope you do get this 2 sine theta cos theta. That is sine 2 theta. So should I not replace it by sine 4x? Should I not replace it by sine 4x? Everybody realized it comfortably. Okay, sir. I have this desire one more time where I want to multiply and divide it by 2 one more time. So denominator was 2 square becomes 2 cube. Numerator also has this one more 2. So shall you or would you tell me what is again 2 sine theta cos theta? So that is sine 2 theta. So it will be sine 8x. So this whole thing vanishes and becomes sine 8x. Correct me if I'm wrong. Okay, one more time. So 2 cube becomes 2 to the power 4 and here I'll get a 2. With that, what I have now is, I hope you do see that, sir, this is again 2 sine theta cos theta. What is that? Sir, that is, I hope you do realize, is sine 2 theta, which is sine 16x. Yes or no? Absolutely. So one more time or one last time I'll do it. This will become 2 to the power 5 and this will become a 2. So 2 sine theta cos theta is again sine 2 theta. So this will be sine 32x. So this will be sine 32x or 2 to the power 5 you may call it. Now this is not unique. This is simple actually. But with this, I want you all to remember this identity here. What is that identity? What is that identity? What is that identity? Which I'll call a hint here. That if you are ever given cos theta into cos 2 theta into cos 2 square theta and so on until cos 2 to the power n minus 1 theta. Then by following this pattern, sine theta in numerator and division and 2 to 2 as well. Thank you so much, Sachin, my friend. So there what you do is that, sir, if you keep doing it like this, you finally get a pattern which is sine. This last angle just multiplied by 2. So this last angle when multiplies by 2 becomes 2 to the power n theta. Denominator, whatever is the coefficient here, just append it here and just give it a sine theta. That's the identity which we have taught you in Trigo in 11th standard in Arjuna batch. So some of you are from Arjuna batch may be able to agree with this, but I hope now you also know this. So technically we are studying methods of differentiation, but eventually we are revising a lot of other chapters as well. Like we have just done a lot of formulae for integration as well. So when I teach you this integration chapter, we may not have to study those again in detail. Similarly, we are revising a lot of identities from Trigo as well. So if you believe, sir, we have wasted our class 11 standard, you don't have this assumption one more time or again. Some chapters with 12th only, we might be able to revisit, like Trigo, like quadratic, like logarithm, like sets. A lot actually. So this identity, if you could apply, I think you got the answer. This is how you have simplified y as. So sir, our y is very well simplified. Yes. So if y got simplified, what is the weight? Shall we not differentiate it? Yes, sir, we should. We ultimately should. Yes or no? So if I wish to differentiate this ddx of y, I want to find. So how will I find it? Sir, it says square of the denominator. So 2 to the power 5, which is technically 32, right? So 2 to the power 5 times what? Sin x should be squared. Then denominator as it is means 2 to the power 5 sin x. Then derivative of numerator, which is sin 32x minus now numerator as it is, which is sin 32x times derivative of denominator, which is 2 to the power 5 sin x. Correct me if I'm wrong. Everybody got this? Everybody understood it? Everybody processed it? Yes or no? All the participants. It's now simply a matter of simplification. Yes or no? So sir, if you want to find or write dy by dx, what you will be doing here is, this is 2 to the power 5, which I'll write as 32 sin x. Now, ddx of sin x is sin x, so it will be sin x. But sir, actually it is not sin x, it is sin 32x. So shall I not? Why is 0, Vijay? I think, okay, they are asking you f dash pi by 4. I did not notice it. Thank you so much, Vijay. So if I first of all find f dash x, what I'll say here is sine 32x. So when 32x, as per chain rule, should be differentiated. So differentiation of 32x will be 32. So one more 32 I'll get. So shall I not say a 32 square it will become? Similarly here, that is already sine 32x. Which part? Oh, how can I be so silly? Why am I making so many mistakes today? I'm really sorry. Thank you so much, Sachin. Thank you so much. So what is happening today? Sine 32x. I'm really sorry for that. ddx of sine x is cos x. I hope you're getting it. So with this, it will become cos 32x and derivative of 32x will be 32. Okay, so Charan is saying, sir, we can just take 1 by 32 out of this differentiation because it is constant. Absolutely. 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 And did I not take it? Okay, why did I make that mistake? Where am I today? Where is my brain today? Yes, 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 yes. I should have taken this outside. I don't know why did I not notice it. Thank you so much. Thank you so much, Charan. I am in a totally different world today, I think, in terms of focus. I should have simply differentiated this. And 1 by 32 is simply constant. But anyways, since I have done it, it's not wrong mathematically, but it is, of course, unnecessarily making it a little lengthier. But anyways, let's get it done. So with this part, if I introduce this, since I'm doing it, let me just finish it with this approach. But anyways, 1 by 32 should have been kept outside because it is constant. Indeed, that's true. So with this is sine 32x, which is like that only. Derivative of 2 to the power 5 is 2 to the power 5, which is 32. So 32 stays outside like this. 32 stays like outside like this. Now sin x derivative is cos x. So cos x you write like this. Of course, with this part, if I have this 2 to the power 5 is 2 to the power 5 only. This needs to be squared. Why will I square it? Denominator should be squared. Of course, I have taken it now. So one more thing is happening here. So I forgot taking it outside. So now I'm squaring it as well. Are you seeing the length? I'm unnecessarily making it here. I'm sincerely sorry for that. But now let's follow the process. I hope you are understanding why am I squaring it. Because I forgot taking it outside as a constant. So I should do this. Are you realizing it? Are you noticing it? Anyways, so with this sin x square is sin x square. Now when you simplify it, this 2 to the power 5 gets cancelled and you are left with 1 by 32 outside. Yes, Vijay, I forgot doing it. So I forgot doing it. That's why I'm now just doing it like this. I hope that's not a problem for anyone. But yes, this is that minute detail. Where is my brain today? I don't know. So this part you should understand. Everybody, yes or no. So 32, 32, 32 will get cancelled. And finally, after simplification, what is going to be the answer? Which was not needed, first of all. I have added one extra step, unfortunately, here. But anyways, let's complete it. So this will be 32 only because 32 gets cancelled here. This 32 will also get cancelled and this 32 will also get cancelled. So you'll be left with 132 here, 132 here, and there will be 1. So this is my final answer. Shall I have sin x also? Nothing is common now. This is my final answer. But we are not noticing one thing. They did not ask you f dash x. By the way, students, what is this? This is your f dash x. We were asked f dash pi by 4. We were asked f dash pi by 4. So let us work on f dash pi by 4. So a very good student, a very good named student, Happy Hoverboard, is saying, why are you so underrated? You decide that. So if I ask you f dash pi by 4, right? So you simply need to replace or substitute x by pi by 4, right? Sin pi by 4, cos 32 pi by 4. So if I start writing it, it is 32 sin pi by 4 cos 32 by 4. So 32 is what? 4 into 8. So it will be 8 pi cos 8 pi minus sine. I hope you do realize it is also 8 pi into cos pi by 4. Correct me if I'm wrong. Whole gets divided by what? Whole gets divided by 32 minus sine. Sorry, why am I putting minus? Again, where am I today? I don't know. Sine pi, this is not minus, this is a product, student. So this is sine pi by 4 whole square. Everybody with me so far? You just need to calculate it a little, but most of the things you may be noticing that here sine pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2, sine pi by 4 is 1 by root 2. So 1 by root 2, 1 by root 2, if I take common, so this is 32 cos 8 pi. I hope you do remember that cos is clearly behaving in this manner, that you have this cos function going like this. So I hope you remember that at any even multiple of pi, cos is 1. At any odd multiple of pi, cos is minus 1. Do you remember it, everyone? So here, what are we dealing with? Sir, we are dealing with even multiple of pi. So this should be 1. So this I have taken common. This is 1, which is plus 32. Now, sine 8 pi. Sir, sine at any multiple of pi is 0. So 0 into anything is 0. So this is clearly 32 by root 2. Correct me if I'm wrong. Correct me if I'm wrong. Everybody got this? Vijay, answer will change now. Yes, you made a mistake. In the denominator also, we have this 32 and sine pi by 4. That is what? That is 2. Yes or no? I hope no other changes needed to be in 32. That's 1 by root 2. This is 1. So this is 32 by root 2. This whole is 0. This is 32 by 2 because sine pi by 4 is not even 16. Vijay, why do we have the 16? We don't have the 16. Okay, you're saying root 2. Yes, that's why we'll have a 16. Good approach. So I hope you do all see that 32 are cancelled. This is, no, there is no 16, Vijay. There is no 16 technically. Because this 32 and this 32 is getting cancelled. So this is simply 1 by root 2. I mean 2 by root 2. So its answer is root 2. Answer will be root 2, Vijay. It's not 1 by 16 root 2. Everybody got this, or is there any confusion? Do let me know. All the students, yes or no? Absolutely. Answer will be root 2. Yes or no? Yes, great. With this, when we proceed further, let's talk about a few more concepts. Now, somebody in the beginning was saying, sir, teach partial differentiation as well. Okay. Shankdeep has said, sir, is this chapter also called first order derivative? This chapter is not called first order derivative, Shank. First order derivative means differentiation for the first time. So if you keep differentiating it successively, second order derivative, third order, and so on, you'll keep getting. So this chapter is technically called Methods of Differentiation or Differentiation technically, but in JEE fraternity, we call it MOD as a short version of it. So here this chapter is trying to teach you different ways to differentiate a function. Absolutely root 2. So did I not write root 2 here? I think I did. So root 2 will be the answer. Everybody, yes or no? I hope I have answered your query, Shankdeep. Now, differentiation of implicit functions. So first of all, what are implicit functions? Let's say if you are not able to segregate a function in x and y. So far, we were comfortably writing a function as, let's say, y is equals to x square into sine x. So this is called an explicit function. Sir, why? Because I can explicitly put x and y aside. Y could explicitly be independently written or expressed in terms of x. But if I take a case where I'm saying that x y to the power x is equals to, let's say, e to the power x y times sine of y upon x. So here in this case, when you try to segregate, I mean, if you try to write y totally in terms of x, you will struggle terribly and you may not be able to. And that's where we say that here x and y cannot be separated. Separated means y cannot be totally written as in terms of x, x cannot be written totally in terms of y. It will be written like this, where they both are there. So there I cannot express x and y explicitly. So this is called implicit function. First of all, do let me know, did you all understand what are explicit and implicit functions? Everybody, yes or no? Now with this part, how do we differentiate? We'll discuss after a break of 10 minutes. Is that okay? So let's have a 10 minutes break and then we'll resume. So you all stay here. Stay here means stay. Keep that phone or tablet or screen or device or laptop or desktop, whatever it is there, open. Go around, hydrate yourself, stretch a little, walk, eat something if you have not eaten, and then come back after 10 minutes. Okay? So we'll be resuming right after 10 minutes. क्यों कर रही थी तो फिर ठीक है तो ऐसा करना जरूरी है Okay everyone, now tell me, am I clearly visible and audible? Students, I hope I'm audible now. Give me a quick response. Yes, I get it now. I hope I'm audible now. Okay. So give me a moment. Let us resume. So, first of all, are you clear with the difference between an explicit function and an implicit function? Explicit means you can explicitly differentiate, write x and y totally in terms of x totally in terms of y. But if x and y are mixed or merged like this, where you cannot differentiate, you cannot differentiate means you can distinguish, you cannot write or isolate x and y. The whole expression is a mixed expression in x and y, where y cannot be totally written in terms of x cannot be totally in terms of y. There it is called implicit function. So how do we differentiate it? Exactly, Sachin, I'm also very excited to explain this. So let us learn it, everyone. This is called the short trick, which I would really appreciate to teach you. But after the standard approach, the decent approach, because sometimes we'll be using the standard approach as well, the direct approach as well. The short trick also, I'll tell you, don't worry, I'll come back to this. But before I tell you the short trick, I'll tell you the standard approach, the direct approach. What does it say here? This is clearly an implicit function where x and y are not segregated, are not isolated. So how do we differentiate it? I will differentiate both the sides with respect to x. I will differentiate both the sides with respect to x. So if I differentiate both the sides with respect to x, it is d dx of xy plus y square is equal to d dx of 10x plus y. Everybody comfortably got this? Yes or no? Now, pay attention everyone. The next thing which we do is, of course, over addition and subtraction, dx can be distributed. So ddx of xy plus ddx of y square, here it will be ddx of 10x, and this will be ddx of y, which is dy by dx. So eventually we are going towards ddx of y. So finally, through some methods or some arrangement, we'll be able to find dy by dx. Yes or no, everyone? Okay, sir, we got it. Now what next? Just arrange it. So, did I write x plus y? Why am I doing these kind of mistakes today? It was xy, right? Now, here, this is xy, which is the product. So can I use the product rule? Of course. So how do we use the product rule? Sir, first function as it is, derivative of second function, which is ddx of y. Listening and understanding, everyone. Plus second function as it is, derivative of first function, so ddx of x. So derivative of x with respect to x is 1. We have learnt it, so it will be simply y. Plus, now here with y square, I'll be using chain rule. What is chain rule? Chain rule says that y, just treat it as x, so it is technically x square for us. What is the derivative of x square? Derivative of x square is 2x. So this will be 2x. But sir, it is not x, it is y actually. So what does chain rule say? So chain rule says that now differentiate y. So differentiate y with respect to x. So when you wish to differentiate y with respect to x, it will be dy by dx. How many of you did not get this? Repeat. I will repeat. Just ask in the comments. What did I just say? I said y square when differentiated gives you 2y. Where? I think dy by dx I have written everywhere, Sachin. I repeat if you did not get it. First function as it is. Derivative of y will be dy by dx with respect to x plus second function as it is, which is y. Derivative of x is 1, which I have not written because y into 1 is y, plus y squares derivative is 2y into derivative of y will be dy by dx as per chain rule. Same. Derivative of 10x is sec square x, and this is clearly dy by dx. Now in the next step, what you are supposed to do is take all the terms in dy by dx on one side. So if I keep all the terms in dy by dx on one side, what I get is, just give me a moment. If I take all the terms in dy by dx on one side, what I get is, pay attention everyone, this, and that. So this is x dy by dx, this is plus 2y dy by dx, and this if comes here becomes minus dy by dx. So dy by dx, if I keep aside, I mean as a common, so x dy by dx plus 2y dy by dx minus dy by dx will be this whole equals sec square x minus y. Correct me if I'm wrong. Did you all get everything whatever I've said? So I think it's simply a matter of now just arranging this data. Don't you think we have cracked dy by dx finally as the numerator sec square x minus y whole gets divided by x plus 2y minus 1. Any confusions? And that's your final answer, students. Everybody, yes or no? Absolutely, absolutely. Vijay, any confusions? Everybody understood this result? How did we find dy by dx? Yes or no? Yes or no, all the participants? Yes or no? Along with this, now let me try and tell you the short trick. There is one more method. Which is called a short trick. Trick is a bad word because it is an approach, by the way. So how do we find dy by dx for an implicit function? Let's talk about that. And some of you, those who were initially asking to explain, sir, partial differentiation also please explain, that also will go through in this part. So everybody who is watching it, pay attention everyone, we are going to discuss a short trick as well. What does it say? If you are ever given an implicit function, like f of x comma y, I mean this is expressed in terms of x and y both, is equal to 0. Then to find the derivative of it, we find dy by dx directly as negative of differentiation of that same expression, whole expression in xy by f x and y with respect to x, keeping y as constant, divided by differentiation of same f of x comma y with respect to y, keeping x as constant. Sir, whatever you said, we did not understand. Can you explain it again? Don't worry, I'm taking an example. So first of all, let me take everything on one side. So can I say it will be written as, for a while, let's say 10x plus y minus xy minus y square is equal to 0. What did I do? 10x plus y minus xy minus y square is equal to 0. So this is your f in both x and y is equal to 0. Listening and understanding everyone, all the participants. Now, you can write dy by dx in one single step. First of all, put a minus sign. This is the short trick which says put a minus sign before the ratio of partial derivative. So partial derivative is written as del x of this f of xy. So differentiate this f of xy with respect to x partially while treating y as constant. Similarly, partial derivative of the same f of xy with respect to y, keeping x as constant. So that's your dy by dx directly within seconds. Trust me, you really don't have to do a lot. How? Let's discuss that. So pay attention everyone, it's a very beautiful trick here. It says negative of, in the numerator, ddx of this, but partial differentiation. So we'll differentiate this whole expression with respect to x, imagining y as a constant. Y will not be a function of x, it is treated as a constant when you talk about partial differentiation. So derivative of 10x is clearly sec square x. Listening and understanding everyone. What is y? It's a constant. Partial differentiation I'm doing. So y is constant, so its derivative will be 0 minus, imagine this, xy. What is y? It's a constant. Imagine 3x. So what is the differentiation of 3x? 3. So y is constant, x is x, derivative of xy, where y is treated as constant, will be y. Everybody getting it? Here, derivative of y square. Sir, y is constant, y square will be constant, so derivative of y square will be 0. How many of you did not understand this partial differentiation? Do let me know in the comments. Everybody understood it? Yes or no? Similarly, if I talk about the denominator, what happens in the denominator, students? Sir, partially differentiate this f of xy with respect to y while treating x as constant. So if I differentiate it with respect to y, treating x as constant. So if x is constant, 10x will be constant. So derivative of 10x will be 0 because with respect to y, we are differentiating it now partially. Y to the power 1 it is. So derivative of y with respect to y will be 1. Now, this xy, now x is constant. We are differentiating it with respect to y. So imagine it is 3y. You're differentiating it with respect to 3, with respect to y. So it will be 3. So derivative of xy with respect to y will be x. Comfortably understanding it, all the participants, yes or no? Now the next thing, derivative of y square, partial differentiation with respect to y, treating x as constant, will be minus 2y. Yes or no? All the participants, do let me know if there is any confusion. It's simply a matter of simplifying it, arranging it. So if I arrange it, what I get is sec square x minus y, like that only. So numerator I keep as sec square x minus y. In the denominator, if I push this minus sign, it becomes 2y plus x plus 1. And I think that's exactly what we got dy by dx through the previous method as well. Yes or no? Everybody understood it? Any confusions, any queries if you have, please ask all the participants. Did you all get this? Is it not a better approach? A short trick you may call it. Yes or no? How many of you are still finding it confusing, this short trick to find the derivative of implicit functions? Got it or no? Not? Yes or no? Everybody. With this, shall we try one more question? Everybody, shall we? This is again a very beautiful, straightforward, direct and decent question. Again, I'll tell you with both of the approaches so that you get comfortable with the derivative of implicit functions, because that's the part where most of the students struggle a lot. So we'll understand it through both of the approaches. Shall we begin? But before I start solving this, you also let me know what do you think could be the answer to this question. Start posting your answers in the comments as soon as you get the answer. Don't use AI, don't cheat. Solve it with your genuine approach, with your genuine and sincere efforts, everybody. So if I use the direct approach, the standard approach, it says simply differentiate both the sides with respect to x. The standard approach says differentiate both sides with respect to x. So it says 4x e to the power xy. So 4 is your constant. So ddx of x into e to the power xy. Are you understanding it? ddx of x into e to the power xy. Understanding it? Is equal to ddx of this. So it will be ddx of y, which is dy by dx, plus ddx of 5 times sine square x, where 5 is of course constant, can be kept outside. So ddx of sine square x. Yes or no? Yes or no? All the participants. Great, great. That's brilliant, Sachin. And everyone else, whoever is watching it, understanding it comfortably, getting it or not. What I did was ddx of this 4 constant outside, x e to the power xy, plus derivative of y is dy by dx, 5 is constant, ddx of sine square x. Everything looks sorted except for one part, which is this. Okay, I'll be more careful with this, but if I simplify this part, this is very well sorted, dy by dx plus 5 sine square x, outside in chain rule. So sine x, if I treat as x for a while, it is x square. Derivative of x square is 2x. So it will be 2x, but x is not x, it is sine x. And then differentiation of x, which is not x, it is sine x. So as per chain rule, derivative of sine x is cos x. Everybody understood it? Everybody got this? Yes or no? All the participants. So now what we do is, I think the left hand side part. This looks a little confusing. So here 4 stays outside. Now Can I use chain rule, product rule, first function and second function? So first function as it is, derivative of second function e to the power xy plus second function as it is, derivative of first function. So derivative of x will be 1. So I hope this is sorted like this, but still there is something here, which we'll do in the next step. There is nothing to worry about so far. Everybody, whatever I've done so far, has understood everything. That's good, Vijay. We'll definitely verify it. Okay, Sachin, that's great. All the other participants also are watching it sincerely. I hope you are carrying a pen and paper with you while watching it and you are solving it along with me. Because trust me, no matter how many times I teach you something, you won't be able to do it until you do it by yourself. So please solve questions by yourself as well. So there I come back to this part. This is the only part which is missing. So this is 4x, yes or no? This is ddx of e to the power xy. So if I use chain rule, imagine this is e to the power x. Imagine this is e to the power x. So derivative of e to the power x is e to the power x. So it will be e to the power xy. But sir, wait a second. Wait a second. This was not x. Outside an approach, chain rule we are using. So as per chain rule, this xy should also be differentiated. So now I should differentiate xy. Yes or no, everybody? Yes or no, everybody? Plus e to the power xy, which is sorted. And on the right hand side, what do we have? We have dy by dx plus 5 into 2, 10, or you can call it 5. 2 sine theta cos theta is sine 2x. So can I write it as sine 2x? Everybody got this part? Any confusions if you have, please ask. Any step which is bothering you, please ask. Don't hesitate. Do write it. I'll re-explain. Now, this part here, which is e to the power xy, e to the power xy is common. By the way, there was this 4 on both the sides. I think 4 was there on both. So I should keep it outside like this, right? Yes. So e to the power xy also I'll take common. So it is 4x, 4 into e to the power xy, and there inside it, it is x. Now, ddx of xy. Again, what I'll use is product rule. So product rule, if I use first function as it is, so this x is already there. Now, first function as it is. So x is there as it is. Derivative of second function. So derivative of y will be dy by dx plus second function as it is, which is y. Derivative of x is 1. So this is how I get it simplified. Yes or no? Plus 1, because this is taken common. So this is plus 1 whole equals dy by dx plus 5 sine 2x. Comfortably getting it, everyone? Any queries if you have, please ask. Everybody. Do let me know if there are any doubts. Everybody, yes or no? Now it's a matter of simplification. So can I do one thing here? If I multiply this x inside, this will become x square and this will become xy. So this xy I'm writing here. This xy I'm writing here. I hope you're getting it. What was there? There was plus 1 as well, right? This was the original expression. So this is x square plus xy plus 1. I'll write it separately so that you don't miss it. So 4 e to the power xy times this x multiplies. So x square dy by dx plus xy plus 1 is equal to dy by dx plus 5 sine 2x. Now you need to arrange it. You need to simplify it. That is inevitable. That much effort you'll have to make if you're not using the short trick. But sir, what if you use the short trick? Yes, you can. In IIT JEE, any competitive exam where steps are not checked, you can. But in boards, you don't use that short trick, which we'll be doing right after this method. So I think it's done. You simply multiply this inside. So it was waste actually taking this outside because I have to do it. This is getting multiplied to this. This is 4 e to the power xy times x square dy by dx plus 4 e to the power xy, 4 e to the power xy times whole of xy plus 1, correct me if I'm wrong, is equal to dy by dx plus 5 sine 2x. I hope no mistake I have committed so far. It's sorted. Now, everything in dy by dx I keep on one side, other things I keep on one side. So this is 4 e to the power xy times x square dy by dx minus dy by dx if I keep on one side. This is how it looks like. On the right hand side, it will be 5 sine 2x minus 4 e to the power xy times xy plus 1. Yes or no, all the participants? I hope there's nothing which is confusing. With this, finally, I will be writing dy by dx as pushing this part there. So that will be my final answer, which is dy by dx, which you receive as 5 sine 2x minus 4 e to the power xy times whole of xy plus 1 gets divided by this thing, which is 4 e to the power xy times x square minus 1. Sir, we understood it, but we thought that this was unnecessarily lengthy. Can we not simplify this? Can we not solve it with some better approach? Can we not have some shorter approach? Can we use a trick here? Yes. So could you teach us that short trick? I have already taught you that short trick, but if you want to learn this through that short trick or technique, let's talk about that as well. So first of all, f of x comma y, I'll bring everything on one side. So I'll say that this is 4x e to the power xy minus y minus 5 times sine square x is equal to 0. By the way, note it down, it is y dash 0 they have asked. Which part, Akanksha Davande, can you ask? Yes, Sachin, we have the short trick. That's exactly what we are going to discuss. By the way, they did ask you f dash 0. So now you'll replace x by 0. So whenever x is 0, what is y? That also we need to find. So let me just get it done. Shall I get that done that part here with this short trick? Will that be okay, everybody? So this is how f of x comma y looks like. Now, the short trick says that you can in one line write dy by dx instead of doing all that hard work which you have done previously. Really, sir? Yes. How? Let's talk about it. First of all, put a minus sign and then in the numerator, partially differentiate this expression with respect to x. Give me a second, everyone. Partially differentiate this expression with respect to x. How? Let's do it. So derivative of this expression with respect to x, pay attention everyone, 4 is 4, then x into e to the power xy. So partial differentiation of x into e to the power xy with respect to x. So if you don't get it, I'll write it as del x of x into e to the power xy minus, pay attention everyone, y is y, which is constant. We are treating y as constant. So derivative of constant is 0. So this part will become 0. I'll write minus 0 if you ever get confused. Then 5 sine square x is clearly 5 into 2 into sine x into cos x. Shall I explain this part again? We have already done it. Derivative of 5 sine square x with respect to x, treating y as constant, will be 5 into 2, 10 sine x, and sine x derivative will be cos x. Chain rule I have used. Comfortably understood the numerator. Are you realizing all that hard work is gone? Or writing the answer in one step. Are you realizing the beauty of this method, this short trick? Everybody who is watching it from the beginning, that implicit functions derivative, you can find that hard work which I put here with these 3 pages of solution which I did can be summarized in one step. That's the beauty of this method, everyone realizing it. So now, in the denominator, partial differentiation of this same expression with respect to y, treating x as constant. So there, 4 stays like that. Everybody listen to me very carefully. X is also constant, so it comes out del y of e to the power xy minus derivative of y with respect to y will be 1. Derivative of y with respect to y will be 1. X I'm treating as constant in the denominator. Now derivative of 5 sine square x is constant now. Sine x will be constant, sine square x will be constant, 5 sine square x will be constant, so it will be 0. I all now need to do is simplify this. Are you realizing the beauty here? The beauty of this method? Yes or no? Sir, what do we do next? I think we solve, but sir, how? Let's do it, don't worry. So first of all, let's differentiate it. First function into second function. Can I do it separately and I'll write it back here? So this ddx of x into e to the power xy, where I'm treating y as constant and differentiating it with respect to x. So first function and second function. So first function as it is, derivative of e to the power xy. So e to the power x differentiation is e to the power x. So it will be e to the power xy. But sir, wait a second. There is xy as well. Imagine y is constant, so it's written like 3x. So as per chain rule, derivative of 3x is 3. So derivative of xy will be y. How many of you did not get this? If you really did not, I'll explain it again. Do let me know. I repeat, what did I just do? I said first function into second function. So first function as it is, derivative of second function, which is e to the power xy plus second function as it is, which is e to the power xy, derivative of first function, which is x. Now what I'm doing is x is x. Imagine this is e to the power x. So derivative of e to the power x is e to the power x, but it is actually power xy, where y is constant. Partial differentiation. So derivative of xy, where y is constant, will be y. So that's why I have put in a y here. And there it already had ddx of x. I mean, partial also with respect to x will be 1. So it will be e to the power xy. So that's my this part. This part when simplified looks like this. So can I directly write this now? In place of this, can I just substitute it by this? So e to the power xy will stay common outside and I have xy plus 1. So this is xy plus 1. 0 simply omits. And there you have 5 into 2, or rather 5 only. What was the sign? Plus or minus? Minus. So this is minus 5 sine 2x. Everybody processing this? In the denominator, pay attention everyone, the same thing we'll do here. The denominator part also when I differentiate. Imagine this, del y of e to the power xy. So now I'm differentiating e to the power xy with respect to y, treating x as constant. So imagine this, e to the power xy with respect to y will be e to the power xy. But sir, as per chain rule, xy should also be differentiated. Yes. So x is constant, y is the variable with respect to y. So xy will become x when differentiated. Are you able to imagine this? So there will be x outside. So it will be x e to the power xy. So this will become x square e to the power xy minus 1. So that's your partial differentiation. And I think this was little less time consuming. I hope you were more faster this time. Everybody agreeing with me on this. But sir, this was not the question. They asked you something totally else. Okay, let's talk about that result. We were asked y dash 0. So they are asking you dy by dx when x is 0. Okay. So when x is 0, sir, this uses something in y as well. So when x is 0, what is y? When x is 0, what is y? That also we need to work out. Okay, so let's work that out. When x is 0, what is y? Let's work on that result. When x is 0, what is y? Let's work on that result. So whenever x is 0, 4 into 0 into anything is 0. I hope you're understanding. 4 into 0 into e to the power 0 into y is equals to y plus 5 sine square 0. So this whole is 0. So 0 is equal to y plus sine 0 is 0. So we cracked that whenever x is 0, y is also 0. So if somebody is asking you dy by dx at x is equals to 0, so they're asking you it at x and y both being 0, 0. That's great, Samriddhi. That's great, Sachin. Good, good, good. Keep it up. So if I wish to know the value of dy by dx at 0, 0, all I need to do is this xy becomes 0. So this is e to the power 0. This also becomes 0. So this is 0 plus 1. This also becomes 0. So this is sine 0. Correct me if I'm wrong. This also becomes 0. So this is 4 into 0. 4 into 0. This also becomes 0 because 0, 0 you're putting here. So this my final answer would be. I just need to simplify it, yes or no. So let's quickly get it done, everybody. E to the power 0 is what? 1. This is 1. So 1. This gives you finally a 4. This is 5 into sine 0 is 0. So this is 0. This is 4 into anything is 0 upon minus 1. And there is a minus sign already outside. So minus 4 negative will be 4. And I think some of you have written this as the answer. Excellent, excellent. That's good, Vijay. That's good, Sachin. That's brilliant. Everybody who was sincerely watching and understanding it, did you all get this? And did you realize how beautiful this approach could be? Amazingly efficient you'll be. You'll be more faster. But one challenge is here. What is that? Partial differentiation you should be now comfortable with. And I think that's not tough. You should just keep it in mind that in numerator, differentiate it with respect to x, treating y as constant. Denominator, differentiate it with respect to y, treating x as constant, and take negative of this expression. That will be dy by dx. Everybody understood how to differentiate, or how to do the partial differentiation, or how to do the differentiation of implicit functions comfortably? Yes or no? Everybody, please reply. If there is any confusion, do ask. I'll re-explain. Shall we move ahead from here, all the participants? Now, differentiation of a function in parametric form. I'll take an example so that we can understand it. So now, x and y both are defined parametrically. Sir, what is this case? When can we have it? I hope you do remember that whenever we see a parabola, so if I'm given y is equals to 4ax square, let's say, of course, this is not the graph in that case. Let's say, I'll take this only standard case, y square is equals to 4ax. So there we define x and y parametrically. So if I wish to define any point on this parabola, we say 80 square, comma 280. So we say x is 80 square, y is 280. So of course, y can be expressed in terms of x, but if it is not done, and we are given x and y in terms of some different third parameter t. So technically y and x are dependent on each other, where y square is 4x or x is y square upon 4a. But if I'm willing to represent both of them in terms of different parameter, let's say t here in this case, then also we can see the derivative coming. That means dy by dx in picture. How? One of the methods is you eliminate this t somehow. This third variable you remove, and finally you write y in terms of x or x in terms of y. But sir, I am stuck. I don't want to solve it further. I just want the answer as quick as possible. Can we? There are both the methods. First of all, if you simply differentiate it on both sides, y square will be 2y. But as per chain rule, derivative of y will be dy by dx. Derivative of 4ax will be 4a, x will be 1, differentiating it on both sides with respect to x. So there I crack dy by dx as 4a upon 2y. So this will be 2a upon y. Everybody understood it comfortably? Okay, sir, we got it a little, but what are you trying to say here? I am trying to say that let's say I don't go with this approach. Let's say in some questions, I'm not able to create this expression, which is y in terms of x, with the help of this parametric form given, where x and y are represented parametrically. I'm not able to. So in that case, can we find dy by dx even without doing this? Yes. How? So there, if I want to find ddx of y, we say y here is given a function in t. So I'll differentiate y with respect to t, I'll differentiate x with respect to t, and I'll take their ratio. That ratio will also give you dy by dx or ddx of y. So what did you just say? Okay, I'll explain it. What I'm saying is, I wanted to find dy by dx. So I am saying find d dt, because y is actually given a function in t of y, which is 280, and find d dt of this x, which is a t square. Getting my point, everyone? Yes or no? So with this, if I simplify it here, what do I get? Can I do it here? This part I'm writing here. I hope you are not having any problems. So 280 when differentiated with respect to t is 2a. So numerator is 2a. Denominator 2. I hope you understand a is constant. T square will be 2t. So it will be, I hope you're getting it, 2at. Everybody comfortably processing it? Yes or no? All the participants, do let me know. How did we find dy by dx parametrically? Yes or no? Everybody, please respond. So here, this will be 2a upon 280. Of course, you can cancel 2a by 2a and answer will be 1 by t. But I don't want the answer in terms of t, let's say, for a while. I want the answer in terms of x and y. So I keep this 2a as 2a. First of all, the answer here would definitely be, undoubtedly be 1 by t. 2 and 2 are cancelled. Answer is indeed 1 by t. But I don't want dy by dx in terms of t, which is perfectly an acceptable answer for a while. If I want in terms of x and y only, so 2a is 2a. But this 280, I know this 280 is y. So if I replace it y, I hope you do know that the same dy by dx we have got. Did you get or understand this parametrical differentiation here? Yes or no? For example, of course, let's say sometimes you could be given, let's say, ellipse or hyperbola or rectangular hyperbola or parabola or some other curve in parametric form, some totally different curve in parametric form. So sometimes you don't get the exact amount of right steps to convert y in terms of x, to write y in terms of x. So there the best approach will be, let's say I'm given something like as y as, let's say, a sine theta, x as, let's say, b cos theta. So of course it is clearly an ellipse. But I hope you realize that here, if I want to dy by dx, I can simply differentiate y with respect to theta, x with respect to theta, and that dy by d theta whole upon dx by d theta will be my answer, will be my dy by dx. Of course, it will be in terms of theta there. Do let me know if you have understood the parametric differentiation, if you all have understood it, everybody. I'll take one more example so that you get it more clearly. There comes a good question. Very decent, very direct, very simple question, just to make you understand this. This is x in terms of theta. This is y in terms of theta. So technically they are functions of theta. So y and x are dependent on each other, but not directly they are given. They're indirectly given that y is in terms of theta, x is in terms of theta. So how do I write it? I want dy by dx. Yes, sir. So if you want dy by dx, parametrically y and x are functions of theta. So what you can do is d theta of y whole divided by d theta of x. Getting it or not? Everybody do respond. So there what we notice is, sir, d theta of y. What is y? Y is a 10 cube theta. And there d theta of x. So d theta of x. What is x? That is a sec cube theta. Correct me if I'm wrong. Everybody processed it comfortably. Great, Sachin. That's brilliant. So with this, if I now use chain rule, I hope you realize a is constant, a is constant. So this a comes out, this a comes out, that gets cancelled. So I don't have to worry about that. So here 10 cube theta. So if I treat 10 theta as theta, so it is theta cube. So as per chain rule, it is 3 theta square, but it is 10 theta. So 3 10 theta square. As per chain rule, this is 10 theta, sir. So 10 theta should also be differentiated. So derivative of 10 theta is sec square theta. Did you all get this part, or are you feeling confused? Do let me know, everybody. Now, denominator also should be differentiated. So there, a got cancelled with this a. Sec cube theta. So imagine sec theta is theta, but it is theta cube with respect to theta. So that will be 3 theta square. So this will be 3 theta square, but theta is not theta, it is sec theta actually, sir. So it should be written as sec square theta. Get my point, everyone? That's good, Samriddhi. Now, the next thing, sir, chain rule should be applied. So chain rule says sec theta should be differentiated. So what is the derivative of sec theta? Sec theta, 10 theta. So it will be sec theta, 10 theta. Comfortably processing this idea, everyone. Yes or no? So now it's merely a matter of simplification. So what I'll do here is sec square theta are nullified. 10 theta and 10 theta are cancelled. 3 and 3 are cancelled. So what am I now left with? In the numerator, 10 theta. In the numerator, it is 10 theta. In the denominator, it is sec theta. 10 theta is sine theta upon cos theta. Sec theta is 1 upon cos theta. So that cos theta also gets cancelled. So ultimately, the dy by dx which you receive is sine theta. Did you all get this? Did you all understand this? Do let me know if there is any confusion. Please ask. Everybody. Yes or no? All the participants. Now, shall I tell you a catch here only? Although I was supposed to tell you later when I would explain you the higher order derivatives, but I want this to be explained at this stage only because we are doing this parametric differentiation. So shall we learn that higher order derivative of parametric functions when functions are defined parametrically? Shall we do that here? If you are okay and comfortable. What is that? Let's have a discussion on that. I hope this question, of course, is understood by everyone. They are not asking you dy by dx. They're asking you dy by dx when theta is pi by 3. So when you substitute theta by pi by 3, it becomes sine pi by 3, sine 60 degree. That's clearly root 3 by 2. How many of you got this answer, root 3 by 2? Anybody who did get the answer as root 3 by 2, do let me know. Everybody. Did you all understand it? Now, before I move towards the next concept, I'll extend this idea into something else, where I want you all to understand the higher order derivatives. And that logic or concept I merge with parametric form. So first of all, what is higher order derivatives? If I'm given y as, let's say, x to the power 5. So dy by dx, which we denote as f dash x also, is given by ddx of x to the power 5, which you say 5x to the power 4. This in the world of maths is written as y dash as well. So whether you write y dash, f dash x or dy by dx, they are the same thing, the first derivative of x to the power 5. Now, if I redifferentiate it, which means I want ddx of dy by dx, which means in mathematics world, we can call it y double dash also, or we can call it f double dash x also. So what do we want, sir? We want ddx. We want ddx of what? Of dy by dx. What was dy by dx? It was 5x to the power 4. So it is 5 into 4, 20x cube. So it is 20x cube. So are you understanding higher order derivatives? Absolutely. Shankdweep, y1 also. Great. So let me add one more thing here. So some books call it y1 also. This will be y2 as per that logic. Everyone comfortable, but don't get confused. Conventionally, we follow either this, this, or this, or this, this, or this. What if I ask you y3 as per Sankalp? What do you think y3 will be? So y3 means in some world y triple dash, in some world f triple dash x, or in some world this ddx of dy by dx is also known as d2 y by dx square. So if I ask you ddx of d2y by dx square, so this can be written as d3x of, d3y of dx cube. So what does it mean? It simply means ddx of d2y by dx square. What was the second derivative of y? That was 20x cube. So it will be 20x cube's derivative with respect to x, which is 20 into 360 x square. So are you understanding this concept of higher order derivatives? First of all the participants, yes or no? But sir, why are we discussing it right now? Because I want to merge parametric differentiation with the concept of higher order derivatives. Can I? Shall I? Everyone. With this, if I merge it, shall I merge it with this question only? What if I ask you in this question only dy by dx as well, d2y by dx as well? In this question only, what if I ask you, forget this whole question for a while. What if I ask you, this is not the whole question. Let's say what happened? What has just happened? Did I undo it? Give me a moment. Wait a second. I removed it all and it all got vanished. Okay, no worries. I'll rewrite it. Don't worry. So let me just copy it and then I'll explain it. Don't worry about that. Let's say this was not the question. The question was something else. So what could be the question? The question is, let's say for a while, something else. Let me just remove this and then I'll tell you the question. Let's say this time the question is to find d2y by dx square. The question is that you should find d2y by dx square. Now, the mistake a lot of students commit here in parametric differentiation while dealing with higher order derivatives, that mistake I'm going to highlight. So pay a lot of attention in this part, everybody. First of all, you help me with few things. Did you find dy by d theta? Yes. What was that? Sir, dy by d theta was 3a. I hope you do remember. 10 square theta, and 10 theta was sec square theta. Remember that, everyone. Similarly, did you find dx by d theta? Yes, sir, we did find. That was dx by d theta. That is 3a. Of course, sec square theta. And sec theta when differentiated is sec theta tan theta. So it will be sec cube theta tan theta if I wish to write it as. So it will be sec cube theta tan theta. Of course, we did discuss one more idea, that if you divide this by this, you will be getting dy by dx, which you got as 3a got cancelled. 10 square theta and tan theta were cancelled. Tan theta you were left with, and there you were left with sec theta. So it was sin theta upon cos theta upon 1 upon cos theta. So dy by dx, you cracked as sin theta. Now the mistake a lot of students commit is this, that let's say if you are asked d2y by dx square. So they say that, sir, we need to find ddx of dy by dx. And what they mistakenly do is they do ddx of sin theta, which is up till this step is correct. But what they next is amazingly wrong. What they do is they simply differentiate sin theta with respect to theta, which is cos theta, and they think the answer is done. And that's a mistake. That is up to them, but 2 or 3 will be the highest they'll ask. Sankalp. So, Shankdweep, I'm really sorry. So, coming back to this, there I hope everybody is realizing the problem. Sir, you are differentiating sin theta with respect to x. Although we know x is dependent on theta, or theta is dependent on x, but here, don't you think theta cannot directly be differentiated with respect to x? So, what I'll do is I'll use chain rule. So, what does chain rule say? Chain rule says that differentiate sin theta with respect to theta. Okay. So, sin theta with respect to theta will be cos theta. But sir, wait a second. Now, as per chain rule, differentiate this theta with respect to x. Chain rule, are you getting it? So, differentiating this theta with respect to x will be d theta by dx. Okay, sir. Now, I want to tell you one more very beautiful fact, that this Newton-Leibniz coefficient, which is dy by dx, is so flexible in nature that it can be written as 1 upon dy by dx. What did I just say? Oh, sorry. This Newton-Leibniz coefficient is so flexible in nature. I repeat, if you want to write dx by dy, then it can be written as 1 upon dy by dx as well. Did you get my point? Did you get something out of this? Which means here, if I could use this data, can I not say that cos theta stays like that, but here in the denominator, this d theta by dx can be written as dx by d theta. Are you all processing it? Everybody who is watching it sincerely. With this idea or thought in brain, I think we are in a very good position to finally say something about d2y by dx square. Because now I'll say this is cos theta, which is very well sorted. Whole gets divided by dx by d theta. What was dx by d theta? So that was 3a sec cube theta times tan theta. So this will be d2y by dx square, which mistakenly students write as simply cos theta. All the students who are watching it sincerely have understood it, that why would this be the answer? Of course, you can simplify this, which is not a major or a huge task. But did you all get this? If you want to simplify, you can. This is finally ddx of dy by dx, which is d2y by dx square, second order derivative of y, which were parametrically defined in terms of theta, both y and x. So there the numerator is cos theta, you don't touch it. But in the denominator, it is 3a sec square theta is 1 upon cos square theta, and tan theta is sin theta upon cos theta. If you wish to simplify this in sin and cos, you can do it like this. Everybody comfortably getting it. So cos go in the numerator. So it is cos to the power 4 theta yes or no, divided by 3a sine theta. Correct me if I'm wrong. Everybody understood it? So that's your final d2y by dx square, that too in terms of theta, everyone. How many of you did not get this? Do let me know. I'll re-explain. Everybody understood that with x and y defined parametrically in terms of theta or t, with higher order derivatives, you just don't follow that process. So here, in a nutshell, if I could make you revise, whatever I did was simply, first of all, this result we did use. Along with this, we were given y and x both in terms of theta. So dy by dx was very well sorted. We did find it as something. But when I was trying to find d2y by dx square, that means ddx of dy by dx, which means I was trying to find d2y by dx square. So of course, what I did was, the problem here was that this dy by dx was a function in theta. This was a function in theta. I hope you do realize this problem over here, that this ddx of dy by dx, when I tried doing this ddx I could do, but dy by dx was a function in theta. So I cannot differentiate it with respect to x directly. So I had to differentiate it with respect to theta, and then theta was differentiated with respect to x, which in a more simpler language can be written as that dy by dx, which you get, would be differentiated with respect to theta, and then theta would be differentiated with respect to x. Or in a different language, you can say you do d theta of dy by dx in the numerator and divide this whole by dx by d theta. That is going to be the formula for d2y by dx square if y and x are given in terms of theta. Yes or no, everybody? Yes or no, everybody? Please ask if there are any doubts. Did you all get this? Everybody understood it? Any questions if you have, please ask. Any queries if you have, please ask. Everybody. Everybody. Do let me know if there's any doubt. This question I'm giving you as a homework question. This question I'm giving you as a homework question. Sir, why as a homework question, and how are we going to receive this question? You are going to receive this question as in a whole PDF, the whole session, this methods of differentiation which we are conducting right now. This entire PDF will be totally yours, that too at free of cost. Sir, how? This all gets uploaded on our WhatsApp channel. So right after this session, we'll be uploading it on our WhatsApp channel. Yes. Sir, how can we access the WhatsApp channel of PWJ English? It is given, the link to our WhatsApp channel is given in the description. So you can follow it after the video. So this is a homework question which I'm giving you, but of course, if you want a hint, if you need a hint, I can give you the hint. Don't you worry about that. So hint is simply this, that this is y. So y is given in terms of x, but they clearly saying you this, that x is a function of t. So y is also something in t. X is also something in t. So parametrically x and y are in t, but they gave you that x and y are a function of t, but y is directly in terms of x will be this. Okay, sir. Then they tell you that dy by dt is 2. Okay, cool, great. And x is equal to 3 at t is equal to 0. Okay. This is not recorded, my friend. And then they ask you dx by dt. So to find it, first of all, find dy by dt. So you will do this. I am just giving you the hint. Otherwise, I'll start solving it completely. And then you will do the whole. I mean, you'll get dx by dt and everything and just substitute the values. So I've given you a little bit of it. Try this by yourself at home and you'll be able to get this question or approach done. Now, let's talk about the category of questions where logarithm will help you in solving a question based on differentiation. I hope you do remember what is the title of this video, the lecture, Methods of Differentiation. So different types of differentiation you will be asked to deal with. So there are different approaches, different ways, different techniques, and those methods we are exploring here. So one of the ways is differentiating an expression through logarithm. Yes. But sir, when do we need it? Why do we need logarithm to differentiate? Let's talk about that. I'll just take a very generic case, a very beautiful or a simple example. Let's say if I'm given something like this. Let's say if I'm given something like this. What am I given? What am I given? What am I given? What am I given? Let's say sine x to the power cos x. Sir, can we not differentiate it directly by using chain rule? You can. There's no doubt about it. But absolutely, Shankdeep, it will make your problem a little simpler. When you deal with this problem, it will look a little, easier or sorted. But sir, how? Let me try and tell you that. Let's say this is a question given to you and you want to differentiate it. Finally, what you want is dy by dx. That's the question. So how do we find it out? What if I take logarithm on both sides? So if I take logarithm on both sides, it will be ln of y. This will be ln of whole of sin x raised to the power cos x. Everybody processing this idea? Cyber crime, my report, my friend. Once this chapter gets over, we'll bring AOD, application of derivatives, then indefinite integrals, then definite integrals, and then definitely area under the curve. So you'll have to wait for 4 more lectures. I'll cover it in a very detailed manner. So all sorts of problem where you're confused with area under the curve, we'll be dealing with them. And I'll tell you a lot of ways to draw the graphs. So when we talk about different approaches or methods to deal with graphs, that these are the different ways through which you can draw the graphs and figure out. That also I'll tell you there. So don't you worry about that. I'll tell you all of those things in that chapter. But right now, let us focus on MOD. Is that okay? So I am saying that we know log m raised to the power n is n log m. So here it will be log of y is equals to cos x whole times log of sin x. Just give me a moment. Let me remove some particular people in front of my eyes so that I stay focused. Everybody. Okay. Give me a moment, everyone. Just wait a second. I need to remove one more person. Okay, we are good to go now. So I am focused. So here, this is how we have defined it. Now this looks slightly easy. Sir, how come you say that this is slightly easy? Trust me, this is indeed. How? Let's talk about that. Let's say now I'm differentiating it with respect to x on both these sides. So log y will be 1 upon y. But sir, as per chain rule, y should be differentiated. So it will be dy by dx is equal to this into this product of two functions. Product rule. First function as it is into derivative of second. Log of sin x. That's brilliant, Vijay. Log of sin x, derivative will be 1 upon sin x. As per chain rule, derivative of sin x will be cos x. So this will be cos square x plus second function as it is. So it will be log of sin x into derivative of cos x. So derivative of cos x is minus sin x. Everybody comfortably got this, or shall I re-explain this? Do let me know if there is any doubt. Do let me know if there are any queries. Please ask everybody. Yes or no? But sir, don't you perform, or should you not perform one more step, that you should take this y there? So finally, what I get dy by dx is y into all of this. But what was y? Y was this. So my final answer will be sin x raised to the power cos x whole gets multiplied with this expression, which is cos square x upon sin x minus log of sin x into sin x, which is sin x into log of sin x. Everybody getting this? Everybody understanding it? Are you feeling confused? Had you been doing it with this approach only, sin x to the power cos x, it would have been slightly tougher or complicated. Sir, you told us a short trick while you were teaching us differentiation of implicit functions. Could you teach us a short trick here as well? There indeed is a short trick here. What is that? Shall we discuss it? So of course, I'll discuss or talk about the second case as well, don't worry. But if I could teach you the short trick to differentiate this category of functions, did I make any mistake? I think I did not. I hope we are good to go. This is what we got, right? This is what we got. But if I could tell you a short trick here, this second method is a very good way to write your answers. What is this? Let's say if I'm given f of x to the power gx kind of a function. So the short trick says that you can directly write dy by dx as differential of y treating fx as constant plus differential of same y treating gx as constant. Cybercrime is putting a lot of appreciation. I think, sir, I have watched your full-length videos of calculus 1 and 2 and also revised watching the long one-shot lecture. It has been brilliantly helped me to excel in calculus. Thank you so much, Cybercrime. If you have genuinely done it and if you are sincerely saying this, we are humbled and obliged. Extremely humbled. And if someone is getting benefited by it, we are really, really, really happy. Thank you so much. Coming back to this, what does it say? Shall I use this short trick there? Okay, sir, what is it? Differentiate this whole while treating the base as constant first, and then differentiate this whole while treating the index, the power is constant ones. Sir, what are you trying to say here? Can you be more specific? Okay, I will. Let me use that same logic here, the same short trick here for this function sin x to the power cos x. Let's say I am given y as sin x to the power cos x. Sir, I don't want to take logarithm on both sides. I want to differentiate it. With that short trick? Yes. So what is that short trick? Let's talk about that. So that short technique I'll be using here. Shall I? So what do we say? You can directly write dy by dx as differentiate this whole while keeping one is constant. One means one time the base and the other time the power. Which means for a while, I will differentiate this sin x to the power cos x, where I am treating cos x as constant. Imagine you are given something like sin x to the power 5. So how will you differentiate it? Sin x to the power 5, sir, will be 5 sin x to the power 4 into derivative of sin x is cos x. Yes or no? So that's what I'm saying. So understand it, everyone. This cos x I'm treating as constant, like 4, 5, something like that. Sin x is the variable. So it will be cos x into sin x to the power cos x minus 1. Getting it, everyone? Or are you feeling confused? But sir, sin x should also be differentiated as per chain rule. So derivative of sin x will be cos x, so cos x into cos x is cos square x. Everybody got this part, or shall I re-explain this? Whatever I did so far. What did I do? I said treat cos x as constant. So it was like sin x to the power something constant, for example 4. So it will become 4 sin x to the power 4 minus 1. Then as per chain rule, derivative of sin x will be cos x. Understood it or not? Everybody, do let me know if there is any confusion. Then what is the next thing, sir? The next thing is, now treat sin x as constant, cos x as variable. Treat sin x as constant, cos x as variable. So don't you think it would be something this kind of a form, a to the power x? And I hope you do remember, we had a discussion on this formula when we did discuss the formula for a to the power x, the derivative of a to the power x. Do you remember that? Here. A to the power x is a to the power x ln of a. That's exactly what I'll be doing or using here. So if I could use that idea, it may look a little confusing, but let me first of all tell you the derivative of a to the power x. So derivative of a to the power x is a to the power x ln of a. So here in this case, if I use that short trick, pay attention everyone, this here is sin x is treated as a constant, cos x is treated as a variable. So a to the power x, the differentiation is a to the power x ln a. So differentiation will be a, which is sin x, to the power x, which is cos x, to the power ln a, which is ln of sin x. But sir, as per the chain rule, should you not put one more thing? What is that thing? A is A, which is sin x, which is constant, no problem about that. But A to the power x. So this cos x you have treated as x, which was not x, which was cos x. So as per chain rule, cos x should also be differentiated. So derivative of cos x will be minus sin x. Everybody got this? Yes or no? Definitely my friend Upmanyu. I know you. We know you from our batches. And if you are genuinely interested in this chapter, you can. So this, when you simplify, is nothing but this result only which we got earlier. But I hope both the methods make sense and you got it. And did you all understand this short trick? Everybody, yes sir. One more idea I wish to tell you, that let's say if you are given something very, very, very lengthy. For example, this. In terms of division and product, like let's say y is equals to sin x into e to the power x into let's say some other functions. Can you tell me like what? Like let's say x cube whole divided by let's say let's say ln x into let's say these are the, let me just avoid it so that we can keep it simple like this. Now one of the ways to differentiate it could be, first of all, apply quotient rule, and then on this apply product rule, which is perfectly fine, nothing wrong in that. But what if I take log on both sides? So ln of y will be log of this. Now can you help me with this identity? Log of mn is a log m plus log n, where m and n both are positive. And you do know this property as well, that log of m by n is log m minus log n, where m and n both are positive. So that same idea, if I extend here, log m upon n will be log m minus log n. So log m will be log of sin x into e to the power x. So log mn will be log m plus log n. Yes or no? Where base is e, don't you forget that. Minus log n, log m upon log n. Log m upon n is log m minus log n. So this is log of x. Now don't you think differentiating here will be a little easier? So just now I came from doing class for maths. It attracts me. Can you please say how much time is it over now? I think 1.5 hours most probably. 1 hour and 40 minutes. We started it at 6. But it will last for 1 more hour, I think so, or half an hour, I think more so. So you can participate. If you are in 11th Upmanyu, you may struggle a little with this because it is 12th class chapter, but still you can try, because differentiation you will keep using in 11th standard. So you will need it. So it's a good idea if you are 11th standard already learning it. Now, if this is simplified like this, differentiating it here would be a little simpler or easier task. Why? Because log y when differentiated is 1 upon y. And of course, as per chain rule, dy by dx is equal to log of sin x is 1 upon sin x. Yes or no? But as per chain rule, derivative of sin x is cos x plus log of e to the power x. The base is same, it is x. So if this whole is technically nothing but what? X. Derivative of x is 1 minus, look at this chain rule, log x will be 1 upon x. So 1 upon x, but x is not x, it is log x. But now as per chain rule, log x when differentiated is 1 upon x. So it will be 1 upon x like this. Great, Upmanyu. We really need people who are genuinely in love with maths. So that's a good idea here. But sir, one more thing you need to do. This y I'll remove from here and bring it here. So this y gets multiplied to this expression here. And what was y originally? Y I'll replace by sin x times e to the power x divided by ln of x. That's my final answer. The same answer you could have produced by using quotient rule and then product rule. That's great, Vijay. That's brilliant. Everybody understanding it, comfortably getting it, all the participants. Any queries or confusions if you have, please ask. Shall we move away or further from here? All the participants. Would you try doing this question? Differentiate log of cos x. Everybody. This question I'm giving you as a homework question. Sir, why? Because exactly this kind of a question we have just done. Sir, what would be the hint here? The hint is really simple. What you do here is take log. So when you take log, you use the properties log m upon n, which is log m minus log n. You use log mn, which is log m plus log n. Don't worry, Akshansh. I'll be explaining the same logic with one more question. Don't worry. Amazing. That's brilliant, cybercrime. I was not aware of it. Brilliant. That's great. Everybody, getting it, everyone? Will you apply it? By the way, Akshansh, don't worry. I'm getting this question done here. Don't worry, guys. Nobody is late. You all are here. You can watch the part which you might have missed. Don't you worry about that. So this question, log of cos x with respect to x, I want to differentiate. What I do now? Try watching it. If you can understand it, it's great. If you do not, watch it from the beginning. Yes or no? So there I'll say that we have two methods. So what are those two methods? One method is take log on both sides and differentiate. Second method is use that short trick. Shall I teach you both one more time? It may get a little confusing, but it is already a good approach. So we should consolidate it with more practice. That's exactly what we'll do. So one of the approaches is taking log on both sides. Yes or no? So if you take log on both sides, this is y, which is equals to ln of x raised to the power cos x. So what does it say? So it says that here log, if you take, so log y will be log of x to the power cos x. So cos x come to the front and it is log of x. Both are at base e. Everybody, are you getting it? That's good, Vijay. That's brilliant. You have already given the answer to the previous question. Amazing, amazing, amazing. That's good, Vijay. Very nice. So now what I tell you next is, everyone, I think we differentiate. So log y when differentiated gives you 1 upon y. But sir, as per chain rule, the derivative of y will be dy by dx. Yes or no? Then sir, here I'll be using product rule. Yes or no? So first function as it is into derivative of second function. So process this chain rule, everyone. Process this chain rule. Log of x. Imagine this is x. So log of x is 1 upon x. So 1 upon x means 1 upon log x. Yes or no? Log of x is 1 upon x, but x is not x, x is log x, into derivative of log x as per chain rule. So derivative of log x is 1 upon x, so it will be 1 upon x. After this session, this entire PDF of our session, method of differentiation, this one shot will be uploaded on our WhatsApp channel. The link to our WhatsApp channel is given in the description, so that whenever you watch or revisit this PDF for your revision, you go through these homework questions and understand them by yourself. Okay, great. That's brilliant. With this part, this is the derivative of the first function. Sorry, first function as it is, derivative of second function plus second function as it is. What is the second function? Log of x into derivative of second function. Derivative of first function. Derivative of first function is minus sin x. Did you all understand this? So this looks cool. This looks great. All you need to now do is just push this y on the right hand side. So this y, when vanishes from here, comes to the right hand side and gets multiplied here. What was originally the y? The y was log of x raised to the power cos x. This is absolutely a good idea to approach these kind of questions instead of using that short trick, which may make you feel unnecessarily confused. Great, great, great. That's brilliant, cybercrime. By the way, what is your name, my friend? Cybercrime. By the way, if you want to do it with that short trick, shall I tell you that short trick as well, if you are comfortable now? What does the short trick say? The short trick says that by looking at this only, in one line directly, you can write dy by dx. Sir, how? So let us do this with that short technique. Let's learn that all later. Sir, what is that? So what did we learn? Akash, sir. Okay, Akash, sir. Good to have you. So, first of all, you differentiate this log x while treating cos x as a constant. So imagine in your brain cos x as a constant, as any number. So it's written like, let's say, log of x to the power 5. So how will you differentiate it? Sir, as per chain rule, first of all, 5 log x to the power 4. And then derivative of log x, which will be 1 by x. This is how I'll differentiate it. That's exactly what I'm asking you. So imagine this in your brain, that if you're asked to differentiate log x to the power cos x, where treat cos x as a constant. So what will be the differentiation? Differentiation will be 5 log x to the power 4, which is 5 minus 1, into, as per chain rule, log x derivative is 1 by x. So that 1 by x should also be brought here. I hope everybody got this. But the story doesn't end here. The story has actually started. This part plus derivative of the same function. Now, previously I treated log x as a variable, x cos x as constant. This time, I'll treat log x as constant and cos x as a variable. Paying attention, everyone? That's great, Shreyansh. That's brilliant. Now, great. That's good, cybercrime. So now, this time, imagine this log x is constant. So constant means like a. Cos x is constant. Cos x is treated as a variable. So that looks like a to the power x. Or if you don't get it, I may write it like a to the power cos x. But forget this a to the power cos x. Can you help me with the derivative of a to the power x? Yes, sir. Derivative of a to the power x is a to the power x ln of a. But so the problem here is that it is not a to the power x. Log x I'm treating as a constant. So imagine this is a to the power x, but it is not x, it is cos x, sir. Okay. So pay attention, everyone. I am wanting to differentiate a to the power cos x. So as per chain rule, absolutely, Shreyansh, that is also a method which I have discussed and I have kept it in the notes as well. You may see it here. That is also a very good approach which you can adapt to. That is also a good idea which you can always use. The same idea I think we have indeed used in this limits also. The same ideas here. But I have already given you two methods. The third method you can apply by yourself. Coming back to this, I am saying here is this idea that here, what am I told here? Pay attention, everyone. A to the power x when differentiated is a to the power x ln a. So it will be a to the power x ln a. But sir, the x was not x. The x was not x. X was cos x. So as per chain rule, cos x should also be differentiated. So derivative of cos x is minus sin x. Everybody processed it. So I'll be doing it here. I hope you all are paying attention. You would not get confused. Everybody. So first of all, log x I'm treating as a variable. So it is a to the power x. So derivative of a to the power x is a to the power x. A to the power x times ln a. So times ln a. What is a? Sir, a is log x. So ln a. But mind you, sir, you made a mistake that it is a chain rule based question where a to the power x had not x, it was cos x. So derivative of cos x will be minus sin x. So you should put a minus sin x as well. So in one line, I was able to do this question with this short trick. Absolutely, Pratyush. If you're asking us, how do we learn to swim well? We swim a lot. How do we learn to cycle well? We cycle a lot. How do we learn to solve problems? We solve problems a lot. So how do we learn to speak? My daughter is 3 years old. We are learning her speaking well. So we talk, we let her speak, we listen. We ask her to write, we ask her to read, we ask her to speak. So with the language, you can do 4 things: read, write, speak, and listen. So do these 4 things. You'll get better at it. I think with your generation, I mean with us also, but with your generation who is too much into technology, has a lot of tools out there. So you can use them, you can avail them. I think in some classes back only, some of the students of our Arjuna or Laksh batch have already told me about a tool. I forgot the name, but if some of you are watching it or attending it live right now, do let him know about that tool so that he can also avail it. At PW also we have a tool. I don't remember the name exactly, but this is an AI tool, an application with which you can talk or converse in English and you can develop the language. So I think there are a lot of applications. There are actually a lot of classes and PW also provides that. So coming back to this, everybody understood this short trick? Yes or no? All the participants? Great. Excellent. With this, I am moving further. Now let's talk about this. Whenever somebody asks you to differentiate a function with respect to another function, the idea is pretty simple. Parametric differentiation, do you remember? If you do remember parametric differentiation, it is same as parametric differentiation. What did I say? Let's say in this case, fx is log of sin x. Let's say gx is under root over cos x. So imagine this. We did discuss that y was, let's say 80 square, x was 280, or I think vice versa. X was 80 square comma 280. So x was 80 square, y was 280. So y and x both were parametrically defined as a function in t. And then we were wanting to find dy by dx. So what did we do? We did dy by dt whole divided by dx by dt. Same thing we can do here. F is a function of x, g is a function of x, but we don't want f dash x or g dash x. We want derivative of f of x with respect to g of x. Are you understanding it? Are you understanding this first of all? Everybody? I am not able to see any chat, Sachin, unfortunately, because I have blocked the people who were creating some nonsense. So you can also use this feature. I can see some relevant comments only. I am not able to see anything wrong or terrible here, because whoever disturbs us, I just remove those people. So I am having some good, decent, standard chat in front of me. No nonsense, trust me. And that you can also do, Sachin. You will be seeing only relevant comments, good comments, which is relevant to this discussion which is currently going on. So coming back to this, I am saying I want the derivative of f of x with respect to g of x. So what is the idea here? I think the idea is really simple. Find derivative of f of x with respect to x and find derivative of g of x with respect to x and take the ratio. And that will be the answer. That's how we differentiate parametrically. That's how we differentiate a function with respect to another function. So are you not realizing they are same? And sir, we know how to do it. We know how to do it. Can we not differentiate log of sin x with respect to x? Okay. So ddx of log of sin x. That's great, Vijay. That's brilliant. You are constantly and actively and genuinely and sincerely, regularly and consistently participating. That's brilliant. Stay focused like that, everybody. And in the denominator, I'll differentiate cos x to the power 1 by 2. Can I write it as cos x to the power 1 by 2? So it looks more doable for you. That's what I'll do. Everybody got this? Everybody understanding it without getting or feeling confused? Yes or no? Do let me know if there is any query or confusion. Please ask. So when I proceed further, what I do or see next is, sir, log of sin x as per chain rule, what is the derivative? Sir, why we divide ddx is operation, but we're treating dx as a number. No, Pratyush. ddx is first of all is an operation. But as per Newton-Leibniz, this is so flexible in nature that dy by dx can be treated separately. Although not just this logic, but a detailed descriptive logic follows those concepts which we have done with the limits. So actual definition of dy by dx is not this. Actual definition of dy by dx, this is an operator, is this, that here limit del x is approaching 0 and you're doing what? Del y. I hope you're understanding. F of x plus del x minus f of x divided by x plus del x minus x. So this is that ratio. So here in this ratio, if I swap the numerator and denominator, the whole operation remains same. So that's why we say that dx by dy here, or rather I'll say 1 upon dy by dx if I do. So it will be simply reciprocal of this. which can be written as dx by dy as well. So change in y with respect to x or change in x with respect to y will be reciprocal of each other. Getting my language? Pratyush, did I answer your query? So coming back to this discussion over here, I am saying that ln of sin x, when you differentiate with respect to x, as per chain rule, log of x is 1 upon x. So that is 1 upon x, but it is unfortunately sin x. And as per chain rule, derivative of sin x will be cos x. So this should be cos x. Did you all get this or shall I repeat it? Whole should be divided by. Everybody got this? Log of sin x is 1 upon sin x. Sin x is cos x. Understanding my language? Whole gets divided by cos x to the power 1 by 2's derivative. So it is 1 by 2 nx to the power n minus 1. So 1 by 2 cos x to the power 1 by 2 minus 1, which is cos x to the power minus 1 by 2, which is cos x to the power 1 by 2 in the denominator. But sir, as per chain rule, cos x should also be differentiated, which is clearly minus sin x, Everybody understood it? Any confusions? This is for JEE, but we are starting from scratch ohm. That's why we are taking you from the basics. Satyam is saying love from Prayas JEE Hindi. We welcome you, Satyam. Thank you so much for so much love and appreciation. We really keep it. So now pay attention everyone. I hope it's simply a matter of rearranging this. So when you rearrange it, it gets sorted and you get the final answer, which some of you have already written in the comments. That's brilliant. Cos x, 1 and 1 by 2 is 3 by 2. So in the numerator, it is cos x to the power 3 by 2 divided by sin x, that is sin square x. Minus sign is already there, 2 is already there, but 2 goes in the numerator. So it is minus 2 over here like that. I hope this is exactly what most of you have gotten. Dance, my friend, unfortunately, it is not the national language. India has 22 official languages and there is no national language we have, unfortunately. Just to correct you factually, dance. Somebody was saying something important. Let me just see that comment. I think cybercrime and a lot of you have written the answer. Yes, Sachin, in that case, just remove them. Just click on those 3 dots and just remove. You'll be free and happy. Whoever troubles you, just remove them. That liberty you have, at least online. So yes, that's great, Vijay. That's good cybercrime. Akash, I think, great, excellent, brilliant, perfect. Everybody understood it. Everybody got this. Any confusions if you have, please ask all the participants. Shall we move further? Now, the next thing which we do is differentiation of a determinant. So what are you talking about? Can determinants also be differentiated? Yes. Matrices cannot be, but determinants can be. Dance, my friend, I would love to. I indeed would love to, and I can, I should, I must. But look at the channel name, PWJ English. So we are supposed to teach you in full-fledged English. So I'm bound to. I hope you're understanding my constraint here, my restriction here. I think 2 times I have told you. Now, shall I remove you so that you can focus on studying and everybody else can also focus on studying and I can focus very well on teaching? Okay, so this person's irrelevant or unnecessary comments are removed in front of me. No unnecessary or irrelevant thing is written there in front of me. Now I can focus. The same you can do if you ever feel something is blocking you from getting focused. Great, cool. So what am I saying here is that if you ever wish to differentiate a determinant, let's say a determinant has this thing. A determinant has, let's say, 2 rows. So first row has fx, gx, hx, and let's say one more function. What should I say? Conventionally, we don't say k or l or what m, f, g, h, I. I should I avoid? Let's say lambda x, right? So these are the 4 functions. So that's your delta x. So one of the ways to solve is what? Let's say I want delta dash x. What is delta dash x? That is ddx of delta x. So one of the ways which is always convenient is expand. So expansion you do, and after expansion you get an expression and you differentiate it, which is an absolutely a cool idea. Absolutely, Upmanyu. Brilliant. Brilliant. Great, great, great. So, so now what I'm trying to tell you is that instead of using this expansion-based approach, what else you can always do is that delta dash x you are willing to find. So you choose either row or column. Let's say I want to differentiate it row-wise. So differentiate first row, I mean f dash x and g dash x, while keeping other rows constant. There is only one other row, which is hx and lambda x, plus differentiate the second row while keeping the other rows constant, which means the first row. So first row will remain unchanged, intact, same, and differentiate the second row, which is h dash x and lambda dash x. If you didn't get my point, I'll explain it with one example. Let's do it here. Let's say I'm given r delta x as x cube sine x, and let's say ln of x, this is 3, 5, minus 7, and this is 4, 2, 2. And then you are asked to figure out delta double dash x, I mean second derivative. So one of the methods is you expand this determinant, you know how to expand it, and find its derivative. The second method is you can differentiate it either row-wise or column-wise. I'm preferably choosing row-wise. So row-wise, if you differentiate it, what you'll do is differentiate first row, keep other two rows intact. So first row 3x square cos x and 1 upon x. Other two rows intact. So 3, 5, minus 7, 4, 2, 2, plus. Sir, is this come in board for determinant? Determinants differentiation, I don't know. I don't have much idea about that, Pratyush, whether it is asked in boards or not. But I think if it is asked in JEE, this is one of the ways which you can apply. What did you just say, Krishna? I did not get this. So now differentiate the second row. Second row has constants. So second row when differentiated gives you 0, 0, 0. Other elements I'll keep as it is. I mean, here I'll have x cube sin x and ln x, 4, 2, 2. But if our determinant has any row or any column has all elements as 0, it will it will be 0. So I don't have to write it. Similarly, if I say or talk about the third row's derivative, great, Sachin, I know that. If I differentiate the third row while keeping the first and second row intact, so first row is x cube sin x ln x, second row 3, 5, minus 7, but third row has constants 4, 2, 2. So if you differentiate them, they'll be 0, 0, 0. And this determinant has third row as all 0. So the expansion of this determinant will be 0. So this whole determinant will be 0. So 0 plus 0 is nothing, so it does not affect you. So finally, this is what you get. I am trying to highlight something very beautiful. If a determinant has only one row or one column in terms of x, other rows or other columns are constants. So its derivative, although it is not second derivative here, it is the first derivative. It is del x, del dash x. So its derivative you can find very easily by simply keeping other two rows as it is. Just differentiate that row which has x or variable. Sir, at what time will you have dinner? Right after this session. Sir, when will this session get end? Once I am done with all the concepts. Sir, when will you be done with all the concepts? Can you tell us the duration? Yes, probably 15 to 20 more minutes, or maybe, yes, around that only. So control your hunger for another 15 to 20 minutes if you're really having some good time here, if you're understanding it, learning it, and if you want to finish it. And I think that much you can today at least compromise. We don't have these lives every day. I think once in a week we have mathematics. So let's learn and enjoy this, everybody. Krishna, I think I have answered your query, something which is bothering you a lot, but I really appreciate your patience. You're watching it since 6 o'clock, I think, sincerely. And I really appreciate it. So just for another half an hour in the worst case scenario. Is that okay? Same, I think, applies to Vijay or everybody else. So everybody got this? Any confusions if you have, please ask. Now coming back to one more idea that, sir, we are not interested in delta dash x, we are interested in delta double dash x. So I think we have the answer now. You really don't have to follow that whole process. You just differentiate the first row. So derivative of 3x square will be 6x. Derivative of cos x will be minus sin x. 1 upon x is what? X to the power minus 1. It is minus 1 upon x square. So it is minus 1 upon x square. And there you have all the constants as it is 3, 5, minus 7, 4, 2, 2. Plus derivative of second row 0, 0, 0 plus derivative of third row 0, 0, 0. So I don't have to write it. Yes, Upmanyu. Integrals will do after this. So once this slide gets over, we'll start AOD actually, application of derivatives, and then I'll start indefinite integrals. Yes, definitely, Sachin. Before ending this session, I'll give you some time to interact with me. Whatever concerns or queries you have, I'll definitely love to resolve and address. I will indeed. Don't you worry about that, Sachin. But right now, shall I continue this? And shall we discuss this beautiful, amazing, a very good quality question here? Shall we, everyone? So this question here says that this is the f of x. Then you are asked to find limit, limit x approaches 0, fx upon x. Okay. So when I say fx upon x, the best way is f0 upon 0. So when I put a 0 here, I hope you do realize 0, 0, 0 I'll get. So what is f of 0? Sir, f of 0, whatever this row and this row is, I don't care. But one of the columns, whatever this column and this column is, I don't care. But this column has all the entries as 0. So if any column or any row has all zeros, the value of the determinant is 0. So I know f of 0 is 0. So in that case, when x approaches 0, it is clearly a 0 by 0 form. So in the case of 0 by 0 form, do you remember a short trick? L'Hopital was a French mathematician who gave us this trick, and let's use this trick given by L'Hopital. So L'Hopital's rules say that whenever you get 0 by 0 or infinity by infinity form, what you do is you differentiate numerator and denominator separately, and that's how you get the answer. Shall I apply L'Hopital? So if I differentiate numerator and denominator separately, so I hope you do get it, that when you differentiate denominator, that is derivative of x, it will be 1. So I don't have to write 1 in the denominator. It is absolutely useless. Shankdweep, sir, when will you cover tangent, normal, maxima, minima, significant increase and decrease in one life, approximation, and everything in the next life, which is called applications of derivatives. So this concept of tangent, normal, maxima, minima, approximation, increase, decrease, global maxima, global minima, change, rate of change, everything in one life in the next session of application of derivatives. You'll have to have patience. Yes, L'Hopital. So what does it say? Differentiate numerator upon differentiate denominator. X is approaching 0. So denominator, when you differentiate with respect to x, is 1. Don't have to write it. So I'll simply differentiate numerator. So limit x approaches 0 on derivative of this. I hope you're getting it. On derivative of this. This will be my answer. I hope you are getting it. Yes or no? So limit x approaches 0 on whole of this. What is this? Derivative of, I will be doing it column wise. Is that okay? So derivative of cos x is minus sin x. Derivative of 2 sin x is 2 cos x. Derivative of 10x is sec square x. Other two columns as it is. So x square x, and this is 1, 2x, 1 plus. Now first column I have differentiated, I'll be differentiating the second column now, keeping first column as it is. So first column is cos x, then 2 sin x, then 10x. Now derivative of x 1, derivative of x square 2x, derivative of x 1. Third column as it is, which is 1, 2x and 1. Everybody getting it? Plus derivative of third column, keeping first and second column as it is. So first column is cos x, then 2 sin x, then 10x. Second column also as it is, x square and x. And then the third column's derivative, 1 will be 0, 2x will be 2, and 1 will be 0. Yes or no? And on this, I'm applying limit x approaches 0. Everyone comfortably understanding it? Any confusions if you have, please ask. Now when x approaches 0, this here is sine 0. Yes or no? This here is cos 0 and that's sec 0. So this here is cos 0, this is sec 0. There also it will be 0, 0, 0. It will be 0, 0, 0. And this also will be 0. But I hope I don't have to write all of this, because once I have cracked this, everything else doesn't matter. Here also, these will be 0, 0, 0, and this will also be 0, 0, 0. So this will be cos 0, sin 0, tan 0. This will be 0, and this will be 0. Everybody processing it. Everybody processing it. Did I make any mistakes? Did I really make any mistakes? I didn't actually. We are going great. Now with this, here also, it will be 0, 0, 0. It will be 0, 0, 0. So this will be cos 0, sin 0, tan 0. And this will be 0, 0, 0. So I think we indeed have gotten the answer. The answer finally which we have received is this, that here, second column is 0. So everything will be 0. I think second row is 0 because sin 0 is 0, 0. So this determinant will be 0. Here, second column is 0. So it's actually 0 plus 0 plus 0, which is ultimately 0. So this limit x approaches 0, fx upon x will be 0, and that's your answer. Everybody got this? When will be the next class? Next class will possibly in the next week, but next week is having Rakhi. So we doubt whether we'll be conducting it or not, but I'll try to, definitely. Where are you from? I am from Indore, Madhya Pradesh, Sachin. Any confusions? Yes or no? Did you all get this or understood it, all the participants? Final question for the day, after which I'll end this session. Okay, those who are wanting to have some good dinner. So here, this is a question, a good question, based on higher order derivatives. Okay, so read the whole question. So first of all, y is equals to cos inverse x. So can I say x is cos y? Don't forget this. d2y by dx square they are asking. Can we differentiate it with respect to x on both sides? So derivative of x is 1. Derivative of cos y is minus sin y with respect to x. So y will be differentiated with respect to x and give me dy by dx. Chain rule I have applied. Good evening, Jagrati. Abhijit Gautam is saying, सर आपका पढ़ाने का तरीका बहुत ज़बरदस्त है, हिंदी मीडियम से होते हुए भी समझ आ रहा है. That's great, Abhijit. That's your ability to understand, I'd say. That great, brilliant. 0 of order 2, can we see order 2 directly without expanding? I didn't get this query upon you. What did you just say? fx is x square whole of 10x minus cos x. So 0 of order 2. Can we see order 2 directly without expanding? Yes, definitely upon you. Yes, I know both of them. Abhijit Gautam, thank you so much. So coming back to this, I know both of them. So here I come back to this. I have cracked dy by dx in terms of sin y. What is that? It is minus 1 upon sin y. It is minus 1 upon sin y. Getting it, everyone? Which is dy by dx. So now, we have cracked dy by dx, which is minus cosec y. Minus cosec y. Now, if I ask you ddx of dy by dx. So pay attention, everyone. There is again a challenge. We are differentiating it with respect to x. So I'm finding ddx of cosec y, right? So again, I'll be using chain rule. So as per chain rule, cosec x, if I wish to differentiate, it will be, I hope you remember, sec x is sec x tan x. So cosec x will be minus cosec x cot x. So what I'll be doing here is minus of minus will be plus. So it will be cosec x, which is y, cot x, which is again y. But sir, you're making a mistake. What mistake? Great. Same here, Upmanyu. Great, good to hear that. I repeat, this is what I've got it. As the derivative of cosec y with respect to y, as the derivative of minus cosec y with respect to y. But sir, you should put dy by dx also. Yes or no? So you should put dy by dx also, which is going to be d2y by dx square. But sir, this question or this answer looks a little incomplete. Indeed, it looks. So how do I make it complete? With some more changes. What changes? What changes? I think simply what you want is d2y by dx square, right? That's what we are expected to figure out. So it is cosec y cot y. It is cosec y times cot y times dy by dx. What was dy by dx? That is minus 1 upon sin y. So it is minus cosec y. So my final answer will be minus cosec square y cot y. Or in some other language, if you wish to write, you can. Yes, Abhijit Gautam. What? Shall I bring him here right now? We have to put absolutely Upmanyu, and that's exactly what I did in the end. Beautiful. Good, Upmanyu. That's brilliant. Great, Sachin. Excellent. Saravan is saying, sir, can you give a recap now? Absolutely not. How can I give a recap of a 3-hour or more than a 3-hour session? The best will be you revisit it. Even if you are really good at differentiation, if you want to do the revision quickly, you watch it at 2x. That feature is also available, right? But that 3-hour or more than 3-hour sessions recap you want? Absolutely not. It's impossible. It's possible, but for me right now, no. So I have kept some more questions for you, which I'm giving you as homework. So once you are done with this session, once you are done with this session, after this session, once you have dinner and everything, visit our WhatsApp channel. The link is given in the description. There, you will find this PDF of this whole session. So in this PDF, you will get a lot of questions, which I have kept here for your homework. A lot of questions are here. A lot of questions I have kept for your homework. So these questions I have deliberately kept for your revision so that you can check yourself, your knowledge, that whether you have understood differentiation or not. So this whole session, you can get or understand or check your ability of understanding by solving these questions. That's great, Upmanyu. Sachin, I have apologies on that, for that request. We are not supposed to. We have done that kind of questions, MRG 53. We have indeed done the same kind of questions and discussed a lot of different methods as well. So those who were asking for a recap, Saravarnarar, I hope I'm pronouncing your name correctly. The recap is we did differentiation. Before differentiation, we have done a lot of chapters, like a lot. So homework is, I have already told you the all questions which are attached in this session. So with this, we are calling it a day. After this session, you will receive these notes on our WhatsApp channel as well. Definitely, I will be there. Great. So with this, any other queries or concerns you have, please ask. Some of you are requesting for some concerns or doubts to be addressed. So whatever doubts you have, I am waiting here for another 1 minute and then we'll be calling it a day. Any other queries or concerns if you have, please ask. Definitely, I will also meet you someday. Whenever I visit your cities, I would love to interact with you or meet you. So any other queries or concerns if you have, please ask. Shall we end it here, everyone? We have done this MRG 53. You just watch this session, the same question, the same category of question you'll watch. Absolutely, absolutely. Up to a great extent, conceptually, Shankhdweep, yes, but to crack JEE Mains or Advanced, you need more practice. More relevant, appropriate, apt practice you need. Great, Sachin. In that case, if I ever visit Uttarakhand, I'd love to visit your place, meet you. No, not true. Great. Definitely. And we are here to teach you in English. Great. Thank you so much for your appreciation and love. Great, definitely. So shall we call it a day, everyone? Yes or no, with your permission? Your Highness. Thank you so much, everyone. You have been a great audience. It was really nice and loving interacting with you all. Thank you so much. Yes, it is enough. Up to an extent, yes. Thank you so much. Good night, everyone. Take a good care of yourself. Good night.